People, I have a query for you. Question answers करने P by Q में होस्ट बन गई ना और मैंने देखा था अभी YouTube दिख रहा है यहाँ पे Here I was asking you P by Qs डिस्कस करने या सीधा नया चैप्टर करना है P by Qs कर लेते हैं जो कल सिखाया था उसके बेस पे यार P by Qs कर लेते हैं ओके ठीक है people at the back of the class hello you group are you part of the class अच्छा तो ध्यान दीजिए we are beginning all right start here we are going to do अच्छा we need the screen to come alive no problem if I say something in Hindi and you're going to understand the concept, just raise your hand and tell me, repeat in English, and I'll remember.
Our lecture सेकंड बिल्डिंग फर्स्ट फ्लोर में टीवी रूम है ना करेक्ट 11 बैच 1
Okay, all right, here we are. तो PYQs कर लेते हैं कल के इस पे based. First question, arrange the following zones in the ascending order in terms of the latitudinal extent of the earth surface. Okay, हमको earth की surface के पे जिस तरह से सारे जोन्स आते हैं वैसे अरेंज करना है तो वी नो कि बीच में इक्वेटर होता है नॉर्मली इक्वेटोरियल जोन कितना होता है एनीवेयर बिटवीन 0 to 5 डिग्रीज 5 to 10 डिग्रीज नॉर्थ एंड 5 to 10 डिग्रीज साउथ ओके तो दिस इज द इक्वेटोरियल जोन फिर उसके ऊपर एक ट्रॉपिकल जोन होता है नॉर्मली हम ट्रॉपिकल जोन को एनीवेयर बिटवीन 0 to 23 डिग्रीज एंड हाफ तक मानते हैं नॉर्थ एंड साउथ में दोनों तरफ या फिर कभी कभी हम वो जो 5-10 डिग्रीज नीचे चला गया था इक्वेटर को उसको छोड़ के बाकी का सब ट्रॉपिकल बोल देते हैं ओके बट आइडियली यू शुड कंसीडर एवरीथिंग फ्रॉम द इक्वेटर टुवर्ड्स द ट्रॉपिक्स एज ट्रॉपिकल जोन ऑलराइट मिड लैटिट्यूड जोन क्या होता है बीच वाला टेम्परेट जोन जो हमको पता है 30 to 60 डिग्रीज नॉर्थ एंड साउथ का जो जोन होगा दैट इज टिपिकली कॉल्ड एज द मिड लैटिट्यूड जोन ओके एंड व्हाट्स द सब आर्कटिक जोन नाउ दिस इज बिलो जस्ट अराउंड द आर्कटिक्स ओके सो 50 to 70 डिग्रीज नॉर्थ टू साउथ शुड बी कंसिडर्ड द सब आर्कटिक जोन ओके नाउ yeah, good. No, 50 to 60 degrees north to south would be 50 to 70 degrees. Sorry, north to south would be considered the subarctic zone. Now there was, sorry, इसका diagram दिखाओ. Sure. Bad at drawing रे. हाँ, see this is the equator. Okay, ये बीच में equator है. अब यहाँ से maybe 5 to 10 degrees जो होगा, that will be the equatorial zone. Okay. So we are saying 5 to 10 degrees, हाँ 5 to 10 degrees north या south तक, okay? उसके बाद 23 तक, पूरा 23 तक आपको मिलता है 23.5 degrees तक you will get the tropical zones, okay? Ideally 50 to mid latitude zone would be considered anywhere between 30 to 60, okay? 30 to 60 जो होगा 30 से लेके 60 तक जो zone होता है that would be considered as the mid latitude zone, that would be the mid latitude zone, okay? This is not very proportional currently, but let's go with what we can do here, all right? And then इसके बीच में से कहीं से तो 50 to 70 का जो जोन है ये वाला जो जोन होगा 50 to 70 का आई एम राइटिंग दिस ओवर हियर 50 to 70 का जो जोन होता है that would be considered the subarctic zone below the arctics, just around the arctics, okay? Just below the arctics would be considered as the subarctic zone, all right? ठीक है? So ideally one way of arranging this is कि you arrange how many degrees they are because that is what the question would mean. But it doesn't make sense if you try to put it in the answer. So I will go with how the zones are arranged from the equator towards the poles. That is how the normal answer would be. And most websites also and most books also choose to be the same. All right. UPSC is not publishing any answer keys, so we are left to our own devices. right? So here we are going with, which is the first zone closer to the equator. We are going with the equatorial zone, okay? And see in the options also, you will see most of the options are beginning with the equatorial zone, okay? So we are going with the equatorial zone. दूसरा उसके बाद वाला कौन सा आता है? Tropical zone, right? So we are going with 1-4 वाला जो होगा option वो. Tropical zone, उसके बाद कौन सा आता है? Mid latitude आता है, and then subarctic. It makes sense in that part also, okay? ठीक है? Are we good here, people? All right. In which among the following states in India, the sun rays are never perpendicular? Never perpendicular. Sun rays perpendicular. Where are the sun rays perpendicular? Only within the tropics. Okay, between equator to, one answer is correct. Between equator to the Tropic of Cancer and Tropic of Capricorn, the sun rays will be perpendicular because the sun can give rays vertically. But after 90 degrees, say the sun can give sun rays. Okay, so we are saying that is the vertical sun. Can the sun go vertical beyond the tropics? No, the tropics mark the limit of the overhead sun. The sun cannot go vertical beyond the tropics. Okay. Now, to consider this, you need to understand that these are all Indian states. We need to know which of these states lie above the Tropic of Cancer. So, you are saying B, 1 and 3. Yep, that would be the answer. Give me a moment. Here we are. Once again, I'm going to be bad at drawing this. You should know that the Tropic of Cancer is Gujarat, Rajasthan, Madhya Pradesh. We are going garam, cheese, badtameez. Okay, so this will give you the exact chronology. In chronology, matlab order or the sequence in which the states lie. So first, garam, G would be Gujarat, R is Rajasthan, M is Madhya Pradesh, right? We are here, Madhya Pradesh. Then you go to Chhattisgarh. अच्छा थोड़ा नीचे से आना चाहिए मैंने. Chhattisgarh, then Jharkhand, then West Bengal, then Tripura, then Mizoram. Okay, these are the states through which the Tropic of Cancer passes. Okay, there is a nice better way, Mira JCP GMT, but I think you will remember these garam cheese badtameez, huh? And it will give you the exact sequence. Sorry, this is a Hindi setback. Can't help that. So you will have to remember that it is Gujarat, Rajasthan, Madhya Pradesh, then Chhattisgarh, then Jharkhand, West Bengal. BA stands for Bengal. Okay, वो जो BA है, that stands for Bengal, and then T stands for Tripura and MZ for Mizoram. Okay, so these are the states. So ये सारी जो states है, all the states lying above the Tropic of Cancer can never ever receive the sun's rays vertically at 90 degrees. Okay, they can never get the perpendicular rays of the sun. Right? So which are those states? We are going with Bihar and we are going with Manipur. Okay, these are those two states that will not get the sun's rays vertically. All right, these are the kind of questions you can expect in UPSC. They will not focus on one single topic. Here, ideally, you should have known key. The funda you have to know is one, first of all, that anytime the sun's rays will never ever be vertical beyond the tropics. Okay, this is this chapter, the one that we studied yesterday. And the second fundamental that it utilizes is knowing the states through which the Tropic of Cancer passes in India. Okay, so these two concepts have been fused together to make this question. All right, so be mindful. This is exactly the kind of questions you can expect in UPSC. All right, so we are going with answer B, 1 and 3. Huh? All right. Next question. Consider the following statements regarding the international dateline. It is roughly 180 degrees meridian, which deviates slightly east and west to avoid land areas surrounded by the Atlantic Ocean. And the second statement says the date to the east of this line is 24 hours earlier than to the west. First line को consider करते हैं, हाँ? Roughly 180 degrees meridian. Yes, वो correct है. It is roughly 180 degrees meridian. Does it deviate slightly east and west? Very true. We knew that it is not a straight line. It is a zigzag line because it is trying to avoid all land. Okay, it is only trying to go through the water. All right, to avoid land areas. And is it surrounded by the Atlantic Ocean? Good Lord, no. It is not surrounded by the. No, it is surrounded by the Pacific Ocean. It passes through the Pacific. Okay, so we should discard the entire statement. Even if one part of the statement is incorrect, we'll have to discard the entire statement. Right? Go to the second statement. The date to the east of this line is 24 hours earlier than to the west. This is the ideal. Okay. Here is USA. Here is Japan. Because Japan is famously known as the country of the rising sun, right? So you should know that Japan said the day will start from Japan, from the side where Japan lies. Okay. So now the question is the date to the east of this line. This is the line. Okay. This is the line as we see it, which is the east side of the line, this side, right? We are saying this is the east of the line. This is the east of the line. We are not talking about a hemisphere, people. We are talking about which is the east of the line. East of the line is this side of the line, right? It is the date in this part to the east of the line is 24 hours earlier than to the west. The normal way in which the dates are arranged are, if today is 2nd over here, if today is 2nd June, here it will be 1st June. Does the statement hold true? Yes, it holds true, right? The date to the east of the line is 24 hours earlier than the this date. ये वाली डेट से 2nd June से 24 घंटा पहले कौन सा डेट था? 1st June था, right? So this statement holds true. Are we good here? So we are going with option 2. B is our answer. Only 2 is correct. Which one of the following is the oldest era in geological history determining the age of various rock types? Precambrian, absolutely. That would be the oldest one, okay? Because Precambrian, very rarely would you be asked the differentiation within that Hadean, Archean, Proto, so we are not going with that. We are just going with Precambrian. Mesozoic, Cenozoic, Paleozoic is all next after that, okay? The first it will be Precambrian, and then after that you would have the Paleozoic, then the Mesozoic, and then the Cenozoic periods. All right. So we are going with option A, right? Option A is the right answer. Question number 80. A geographical grid has lines that run east to west around the globe to mark latitude. So we are saying lines that run east to west, and they are called as latitudes. And then there are lines that run from north to south, from North Pole to South Pole, which indicate longitudes. Is this correct? Yes, both statements are correct. No, it's not correct. It is correct. Both statements are correct, right? C. Both statements would be correct. You know, now this is called as a proper grid. The longitudes and latitudes together make up a grid, and those two together can spot a location. Like if you want to spot a location for a certain place, then you would require both the latitude as well as the longitude. Okay, at least on the map. Question 59. In terms of geological time scale, the Quaternary period consists of 2 epochs. Which are they? Pleistocene, Pliocene, Holocene, Pleistocene, C, Pleistocene, Miocene, Holocene, Eocene. क्या बात कर रहे सर आप? बी लग हाँ, Holocene, Pleistocene ना? That's your answer, right? B वाला जो आप बोल रहे हो? This is what you are looking at. See, this is the Quaternary period. Yeah, this is the Quaternary period, and within that, these 2 epochs lie. Okay, first is the Pleistocene epoch, and then is the Holocene epoch. Okay, so we are going with that. Holocene and Pleistocene. Okay, those are 2 epochs, right? This was unexpected actually that year. We were not expecting this kind of a question. You want to see the thing again? No, okay. You're good. All right. Question 60. Which one of the following is the correct sequence of arrangement of the given planets in a descending order of their density? Okay. Good. Let's go there. We know for a fact that Earth is the densest, Saturn is the least dense. Okay. So even if you're not aware of it, you are going with these 2 options, where Earth is the greatest density wala body and Saturn happens to be the least density. Okay. Now, if you are worried if you do not know whether Venus has more density or Jupiter has more density, you should always remember that the inner planets, the terrestrial planets, will always have a greater density. They will always have more density than the gas giants. Okay. Okay. So obviously our option is going to be this, not this. Earth, then Venus, then Jupiter, then Saturn. Okay, consider the following statements. First is distance between the longitudes becomes 0 on North Pole and South Pole. Distance between the longitudes is maximum on the equator, and number of longitudes is more than the number of latitudes. Very correct. Distance between latitudes and all the latitudes and all the longitudes are going to join at the North Pole and the South Pole. Okay, they will all come together. It is a single point over there. They converge at the North Pole and South Pole. So clearly the distance is 0. The statement is correct. No, distance between longitudes is maximum at the equator. See, we are saying these are those different longitudes, okay? These are those longitudes, different longitudes like this, okay? And where is the distance maximum? At the equator. At the equator, the distance, sorry, gravitational, the weight, you're talking about the weight. Acceleration due to gravity and hence the weight. Okay. Distance between the longitudes is maximum on the equator, and distance and number of longitudes is more than the number of latitudes. Yes. How many longitudes do we have? 360. Okay. How many latitudes do we have? 181, which is a greater number. Longitudes, obviously. Okay. So the number of longitudes is greater than the number of latitudes. And this was a question they asked this time also sometime, I think. This is the question I was talking about. If it is 12 noon in New Delhi, what will be the time in London, UK? Always have a reference line. We are saying this is 12 noon, this is noon, and where are we? We are at 82.5 degrees east. Okay? 82.5 degrees east पे हैं हम, and this is noon over here. Okay, India का standard meridian क्या है? What is India's standard meridian? 82.5 degrees east. Okay, this is what the time is. Noon is the time at 82.5 degrees east. What will be the time in London, UK? I don't need to draw a map for this, but what is the B वाला option है? अरे B क्यों होगा? A. Who said A? Thank you. Right. First of all, if we are looking at London, UK, where are we? Prime meridian, right? We are talking about the prime meridian. It is 5.5 hours behind India. What is India's time said as GMT plus 530 hours, right? So clearly we are 5.5 hours ahead of London, or London is 5.5 hours behind us. Okay. So now if it is noon in India, go 5.5 hours behind. From 12 o'clock in the afternoon, go 5 hours behind. How much is that? 7 o'clock in the morning. Okay. Go another half an hour behind because we are taking away 6:30. So we are at 6:30 a.m. in the morning. All right. If you do not want to do those major calculations, break it down in smaller chunks and then subtract the time or add to the time, because this can be very confusing if you're not used to doing this always. All right. Okay. Are we good here? And please remember that nobody is mentioning DST or something. Satta iska satta, no, what satta can we have? We only have that thing over here. 1 degrees, 4 minutes, 15 degrees, 1 hour. That is the only satta we know here. The satta is that you need to be a cricket fan and you need to watch a lot of bilateral series to understand that how the time works here. And even then, when you make those calculations, you're going to apply DST to it, because in real life, in daily life, Britain does use GST. Okay, so if DST is applied, then clearly you have go back a hour, 1 hour, right? Then the difference is just 4:30 hours, 4.5 hours. Okay, which one of the following cities in the world would represent the greatest linear velocity of rotation of the Earth? Great question. Love the question. Tell me. We are talking of a city which will have the greatest linear velocity of rotation. You should know that the Earth as a whole, why Sweden? Poles की तरफ है. Okay. So, okay, we'll revise the concept again. We are saying that when the Earth rotates, ऐसा rotate करता है उल्टा. Okay, so when the Earth is rotating like this, what happens is the equator will rotate at the maximum speed. Okay, so you will have the maximum speed at the equator. All right, as in how you go upwards to the poles, the speed keeps on reducing. The speed of rotation will keep on decreasing. Okay, and it will become almost zero at the poles. Okay, so the speed of rotation is maximum at the equator, and it goes on decreasing as in how you advance towards the poles, and it will be zero, almost zero at the poles. Okay. So we are saying that we need to find a city which is closest to the equator. Okay. Now you need to find a city which is closest to the equator. You are looking at Kampala, Uganda, St. Petersburg, Russia, Madrid, Spain, and Stockholm, Sweden. Let's find absolutely correct. Okay. ये जो ब्राजील का कंडा है ना, this shoulder of Brazil, this is somewhere where your equator lies. Okay, that is the line for your equator. Okay, now look at Kampala, Uganda. It is somewhere over here. Okay, we are spotting Kampala, Uganda somewhere in this region. Okay, this is St. Petersburg, Russia. All right, that is St. Petersburg, Russia. Sweden, Stockholm, Sweden there. All right, and what else was there? Spain, Madrid. We are looking at Spain, Madrid, which is closest to the equator, Kampala, Uganda. Okay, so we are going with that city which is closest to the Equator. That will have the greatest speed of rotation. No. What will happen if you are flying east across the international date line? 24 hours, very correct. This is the international date line. This is USA. This is Japan. Which way are you trying to fly? East. Okay, you're trying to fly east, meaning you're trying to go towards the USA section. Okay, so first of all, this is never a calculation for 12 hours. Okay, when you are making calculations regarding the ideal, the calculation will always be 24 hours. You either gain 24 hours or you lose 24 hours. Okay, so we are looking at, if you're crossing towards the east, what are you going to do? Are you going to gain 24 hours or lose? Gain, always gain. Because that day is a date earlier. Okay, so you will get to live that day again, which means you will gain that day. Okay, okay. We are good here, na people. They keep asking you this question. This funda needs to be really clear that when you go cross over to the east, you will gain 24 hours. When you cross over to the west, you lose 24 hours. Okay. The prime meridian does not pass through which one of the following African countries? Morocco, Algeria, Mali, Ghana. Morocco, absolutely correct. Which were the 5 African countries that it passed through? Algeria, Mali, Ghana, Burkina Faso. Burkina Faso. That was the 5th country. और एक था ना, तुम सब फ्रांस गए. Togo was another African country through which the prime meridian passes. Okay, ठीक है, चलेगा. Piecing together, क्या हो गया? Morocco is the answer. Morocco से नहीं pass करता है. It passes through Togo, Mali, Ghana, Algeria and Burkina Faso. वो सट्टा किया था ना आपको, तुम सब फ्रांस गए. So you were not in the class at that time. No worries. We gave a satta yesterday for all the yeah, you can check it out in the notes. It's definitely there in the notes. लेकिन सट्टा नहीं लिखा है मैंने वहां पे. This is the satta for it. तुम सब फ्रांस गए. T stands for Togo. U stands for UK. M for Mali. S for Spain. Sub A is Algeria. B is Burkina Faso. France is France and Gaye is Ghana. Okay. So that is tum sab France gaye, right? Okay, question 96. Piecing together puzzle of geologic time to create and analyze historical maps of the earth is known as paleoclimatology, paleogeomorphology, paleolithology, paleogeography. Paleo ka matlab something ancient, something old, something really ancient. Okay, so we are talking, that is paleo. What does climatology deal with? Atmosphere, climate processes for the climate, humidity, temperature, pressure, all those things. So clearly we are not talking about that. Okay. What is morphology? Morphology is the surface of the earth and the changes that happen in the surface of the earth. Okay, this can be a little close. Geologic time to analyze historical maps. You're looking at historical maps of the earth, how the earth used to be over a period of years. Okay, over the course of time. Lithology only deals with rocks. Okay, we are only talking about rocks now. We are only talking about the rock structure. So you are only maybe looking at the crust or maybe how the rocks have changed and so on and so forth. Okay, paleogeography would consider everything. That would consider the entire geography. It will give you how the geomorphic structure has changed. It will tell you how the lithological structure has changed. It will tell you what the vegetation, the flora and fauna has been through. That would be a proper historical map. Okay, so paleogeography has to be the answer. That has to be your answer. All right, because otherwise you can't just make a historical map of the earth. You're not being asked to make the historical map of a certain aspect of the earth. You're saying pure earth ka historical map batao. Just make a historical map of the earth on whole. Okay, so clearly you will have to go with geography. So your answer is going to be D. All right, 96D. This is a good question. In the group discussion, dikhai de raha hai? Yeah. In a group discussion on shape and size of the earth, 3 students stated the following points. Student 1 said, the shape of the earth is basically an oblate spheroid. Okay. Student 2 went and said, the polar diameter of the earth is more than the equatorial diameter. Okay. Student 3 said, bulge along the equatorial region is due to the revolution of the earth. Now, which of these students is correct? Or how many of them are correct at the same time? Let's analyze the first one. Shape of the earth is basically an oblate spheroid. Yes, yes, 100 times yes. Okay. That is the technical name of the shape of the earth. Okay, that it is an oblate spheroid. Santre jaisa. It looks like an orange. It bulges in the middle. It is flat at the poles. Okay. Student 2 said that the polar diameter of the earth is more than the equatorial diameter. No, we just negated that fact in the earlier statement. If the earth bulges in the middle, clearly the equatorial diameter is going to be greater than the polar diameter, right? So clearly the second student is wrong. Student 3 says bulge along the equatorial region is due to the revolution of the earth. Rotation of the earth. Very good. Okay, so this statement is wrong again because it is not due to the revolution of the earth. It is because the earth spins on its own axis. Okay, so because of the fact that the earth rotates about itself, that is why it gets that bulge. Because of the rotation, the earth gets that equatorial bulge. Okay, so only student 1 is correct. So we are going with option A. Zoom, zoom. Question 109. While watching the news, you hear about a place of which you have never heard earlier. Okay? You want to know more about the place and you want to locate it on the map. Which of the following is are required for you to be able to locate the place on the map? Okay, now you are going to visit a place on the map that you've never been to before. Okay, so clearly you need coordinates. Okay, which one do you need? Latitude, longitude, or both of them, or even altitude? Just both. Why? Why just these two? Because it is a map. It is not a real life place. Okay, you don't need to check how high the place is. You do not need the altitude of the place. Map is on paper. It's 2D, right? So clearly, all you need is just the latitude and the longitude. Okay, this is just confusion for you. Which one among the following planets is largest in size? Here we are talking about all of the terrestrial planets. Which among these planets is the largest in size? Huh? Oh, remember yesterday I had told you whether it is mass or whether it is radius or whether it is the density, Earth will always figure first. Okay. Among the terrestrial planets, Earth has the largest mass, it has the largest radius, and it has the greatest density. Earth has the greatest density among all planets in general, but it has the greatest density among the terrestrial planets as well, then, obviously. Okay. So Earth is the largest among size. Agar Earth se chota kuch hota hai, some planet lesser than Earth, it would be Venus. है ना? Correct. It would be Venus, and then Mars, which is almost 1/3 the size of the Earth, and then Mercury, which is really chukku. Okay, so we are going with Earth over here. Next question would be, longest parallel of latitude कौन सा होता है? Which is the longest parallel of latitude? Equator. Okay, because clearly it is bulging, it is the largest one, and poles are simply dots. Poles are, the parallels of latitude are circles, and they will keep on becoming smaller in size as and how you go towards the poles. Equator, equator. A similar question. Which one of the following is the longest latitude? 0.0. C. Okay, 0.0 degrees would be the largest latitude. Yeah. Capricorn or Cancer. लीनियर डिस्टेंस सेम होना चाहिए उसका because अर्थ में ऐसे कोई मेजर ये नहीं होने चाहिए ideally. It should be the same because it is anyways an imaginary line. We are not imagining any kind of disruptions there or any kind of irregularities or anomalies. So clearly it should be of the same latitude. If it is 12 noon in India, on which meridian will it be 7 a.m. on the same day? You need to know on which meridian will it be 7 a.m. on the same day. Okay, so we begin here. The first thing to determine is that what is your reference point and reference time and reference point? The reference point is India. Okay, we say India is at 82.5. And what is the reference time? Noon. Okay, so this is your reference. This is going to be your reference. Okay, very good. How do you go back to a meridian on which it is 7 a.m. that day? Which way do you go? Are you reducing the time or you're adding to the reference time? You're reducing, you're subtracting from the time. If you're subtracting from the time, obviously you're going towards the west. Okay, you're moving westwards. So now you come to this meridian. What is the difference? Time difference kitna hai? 5 hours, right? The time difference is 5 hours. It was noon over here, it is 7 a.m. over here. Okay, so the time difference is going to be 5 hours. How does 5 hours translate into degrees? 1 hour 15 degrees, 5 hours 75 degrees, right? So what you are essentially saying is that there is a difference of 75 degrees, okay, between these two meridians. So if there is a difference of 75 degrees, you need to subtract 75 degrees from 82.5 degrees to get this particular meridian. What is that? 7.5 degrees east. Okay, you're still in the eastern hemisphere. Is that good? Still in the eastern hemisphere. You have not moved on to the western hemisphere yet. Okay, if you cross the prime meridian and then you still have to add on more degrees, then you would move on to the western hemisphere. Okay, suppose imagine this really happens, that there really is such a big time difference. Let's say there is a time difference of 8 hours. Okay, अगर 8 hours का time difference होगा तो 15 8s are 120 degrees, right? तो which means कि 82.5 यहाँ पर and बाकी का कितना बचता है 37.5, right? So 37.5 on this side. So we are saying this is prime meridian. Okay, if this is the prime meridian, now you move 37.5 degrees east, okay, west. Okay, so this way, this is going to be that 37.5 degrees west longitude. Okay, and remember, like we started from here, if this is 0 and we started 1, 2, 3, 4, 5, 6 degrees east from here. From here also we'll start in the same way 1, 2, 3, 4, 5, 6, 7, 8 degrees west on this side. Okay, जीरो प्राइम मेरिडियन के बराबर दोनों साइड पे 1, 2, 3, 4 ऐसे रैपिड सक्सेशन में चला जाता है वो. Okay, please remember this, people. In my opinion, UPSC doesn't ask you such questions. These are very well reserved for proper civil services preliminary exams. You don't understand that? Oh, okay. Which part didn't you get? Okay, no problem. The reference was noon and the line is 82.5 degrees east, India. Okay, that is the line. We say it is 12 noon in India. On which meridian will it be 7 a.m.? Okay, 7 a.m. money you have gone back in time, right? You are subtracting from the reference time. How much 5 hours you're subtracting from the reference time? If you've subtracted from the reference time, clearly you're going towards the west. Okay, this is your reference time and you're going westwards from here. Okay, so you're moving westwards from here. Okay, now what is the time difference? You say the time difference is 5 hours. All right, so 5 hours, if this is the time difference, can you translate it into degrees? What is the difference in degrees? 1 hour translates to 15 degrees. So 5 hours would translate to 75 degrees, right? 15 5s are 75. So we are saying 75 degrees का difference होगा. There will be a difference of 75 degrees. So 82.5 minus 75 should give you 7.5 degrees. Okay, so we are saying this particular meridian is 7.5 degrees east. Okay, that is the meridian. No, it is not yet west. It would be west if we had crossed 82.5 completely, reached prime meridian and then gone further. We are still in the eastern hemisphere. The hemisphere is still east. We have just gone westwards in time. Okay, but we are still in the eastern hemisphere. Which of the following planets has the density? We are talking of which of the planets has the highest density. Earth, any day, Earth. Earth has the greatest density ever among all the planets. Jupiter is too massive and it is completely made up of gas, which is why it has almost the third least density in the entire universe, in the entire solar system. So Saturn has the least density, third least. So Saturn has the least density, followed by Uranus. Uranus is less denser than Saturn, and Jupiter is even less denser than, Jupiter is a little more denser than Saturn and Uranus put together. Okay, great. Question 106. The answer is Earth over here. Is great. Greatest ही पूछा ना, highest density is Earth. Which one of the following hypothesis or theory explain the origin? This is how UPSC poses the question. Big Bang Theory. Big Bang Theory. Okay. There is only one particular theory for the origin of the universe, and it is going to be Big Bang Theory. The rest of them, whether it is nebula hypothesis or binary star theory or planetesimal hypothesis, are all solar system के origin theories. They are not origin theories for the universe. Okay. So we will go with Big Bang. See, Big Bang is the answer. All right. Okay. Moving forward, this is a good question. Can you see it? You can see it, right? Yeah. Which of the following are environmental effects of the rotation of the Earth? First, daily or diurnal rhythm in daylight and air temperature. Second is flow path of both air and water are turned consistently in a sideward direction. And three, movement of the tides. और अगर अर्थ स्टिल रहा और रोटेट नहीं किया तो हम तो मूव करेगा लेकिन हाँ खत्म है वेरी करेक्ट लेकिन टाइड्स का इफेक्ट आने के लिए इट इज नॉट जस्ट द ग्रेविटेशनल अट्रैक्शन द फैक्ट दैट वी एक्सपीरियंस टाइड्स एवरीवेयर इज बिकॉज द अर्थ कीप्स ऑन रोटेटिंग so we'll have to add that effect to the rotation as well tides has to be an effect for the rotations as well और वो 2 का क्या करेंगे उसको भी डिस्कस करेंगे ना सर ऐसे क्या बात करें आप ओके फर्स्ट आपको क्लियर है डेली एंड डायurnal रिदम इन डेलाइट अभी अर्थ स्पिन करता है ओके सो आधे हेमिस्फीयर को डेलाइट एक्सपीरियंस करता है हाफ ऑफ द हेमिस्फीयर एक्सपीरियंसेस नाइट टाइम एंड दैट इज द डेली डायurnal रिदम राइट दैट वी विल गो थ्रू अ डे विल गो थ्रू अ नाइट क्लियरली डे टेंपरेचर्स आर हायर नाइट टेंपरेचर्स आर लोअर है ना वील गो थ्रू दैट ओके सो दिस इज डेलाइट एंड एयर टेंपरेचर का प्रॉपर रिदम वील एक्सपीरियंस राइट अग्री सो वी गो विद द फर्स्ट स्टेटमेंट दैट इज एब्सोल्युटली ट्रू The second statement says flow path of both air and water are turned consistently in a sideward direction. Now this is important. Have you ever heard of the Coriolis effect? You've heard of the Coriolis effect, right? Coriolis effect. Can you explain that? Alex, the Coriolis effect it is called as the Coriolis force, but ideally it should be just called as the Coriolis effect because the effect happens because of what is happening. Like I said, the Earth rotates differentially. Okay, it is fastest at the equator and lower. The speed starts from decreasing as and how you go upwards. Okay, the Coriolis effect experiences the Coriolis effect happens because both the places. So, say suppose for example there is an object which is traveling from this place to say this particular latitude. Okay. So if there is an object which is traveling from, say, the equator towards this latitude, for example, like ships travel or, like an airplane goes, we are talking of long distances where you're traversing multiple latitudes, okay? We are not talking of cricket balls and baseballs, okay? We are not talking of such small distances. We are talking of larger distances. So we are saying when there is an object which travels from one particular latitude to another, it is going to experience that difference in the speeds, okay? And it will go with the speed at which it started. Okay, so this will always go at the speed at which it started and it will reach a different place. If this is the direction, it will reach over this part. It will reach in this part instead of reaching here. This should have been the ideal way where it should have gone. This should have been the ideal process for it. हाँ, इक्वेटर से अगर इक्वेटर पे आना चाहिए नॉर्दर्न हेमिस्फीयर में किसी भी डायरेक्शन में जाओ वो राइटवर्ड्स ही घूमेगा जरूरी नहीं है हम इक्वेटर से 30 डिग्री लैटिट्यूड तक जा सकते हैं ना क्या बात कर रहे हैं हम अफ्रीका से यूएस नहीं फ्लाई करते क्या करते हैं ना सर नहीं हवा भी उल्टी चलती है ना हवा भी ऐसी चलती है so on the eastern side of the hemispheres you will get this motion you will get this upward going motion on the western side of the hemispheres you will get this downward coming motion which come towards the equator and on the eastern hemispheres or on the eastern side or eastern coast you will find the motion where it goes upwards towards the upper latitudes. That is the general. If you're looking at ocean flows and air flows, it is usually what. Oh, you're talking about planetary winds. Northeast planetary winds. Okay, but that is also fine. That is the pressure-induced winds. तो वो तो उसी रास्ते आ गए. There is no other way of going about that. This is generally any motion. We are discussing any motion here. Okay, ठीक है? Sorry, I didn't quite get when you said airflow. Teachers, I have not been teaching you guys for a long time now. Here we are. So we are saying the flow path of both air and water. See, I'll do this again. Okay, so we are saying this is the equator. This is another latitude. Okay, we are at point A. We were supposed to go to point B. This is the track route. Okay, that this is the way the route should have gone. Okay, this is how we should have gone. Okay, if we let it be a free flow, okay, if we do not try to control the speed, do not try any course correction or something, the object will actually land somewhere over here. Okay, this is what really happens because this is moving at a slower speed. This thing is moving at a slower speed, whereas this particular latitude is moving at a higher speed. The object that started from this latitude, equator, from point A, has the speed for this particular latitude, has the speed for the equator. So it is obviously traveling at a greater speed than this particular latitude. So it will land a little farther from the original place where it should have landed. Okay. And this is called as the Coriolis effect, where in the northern hemisphere, any freely moving objects, which are crossing latitudes, will be deflected towards the right in the northern hemisphere, and they will be deflected towards the left. They will be deflected towards the left in the southern hemisphere. Okay, this you need to remember. And this effect is called as Coriolis effect. The effect is because of differential speeds at various latitudes. Okay, various latitudes are moving at different speeds, and the object which is moving between these latitudes will always hold on to the speed at which it started, of the latitude at which it started. Okay. Okay, so that is why the difference in speeds and hence the difference in the locations of reaching destination जो होता है उसके difference में ये उसका difference इसलिए आता है. Okay, so this is the flow path of both air and water are turned consistently in the sideward direction. This is also true. Okay, please remember it will always be deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. Okay, that is true of it. And lastly, movement of tides. ये तो हमने establish किया कि अगर we agree that the tidal attraction is the tides happen because there is a gravitational attraction between the moon and the earth. Okay, but it is because of the earth that keeps moving and rotating. Because of that we experience tides at every different places. Okay, we experience tides all over the earth. We just witness the rise and fall of water wherever water is present. Otherwise, tides are happening everywhere, okay, because the earth keeps moving everywhere. So at any given point of time, you will have 2 high tides, 2 low tides. Okay, this is definitely happening everywhere. We are going with options 1, 2, and 3. ये जो बच्चे हैं उनको पता है क्या कि they are making such a lot of noise? ऐसे यहाँ से शुश करना पड़ता है उनको. Shush is wrong ना. अपने को मुन्ना भाई में बताया था shush is wrong. No, I agree, but I don't know how much politeness would work here. All right, moving on. Black hole. We are discussing black holes. Okay. Black hole is a huge black star which has 0 acceleration due to gravity on its surface, a star which has moderate acceleration due to gravity on its surface, star which has collapsed into itself and has large acceleration due to gravity on its surface, star which has collapsed into itself and has 0 acceleration due to gravity on its surface. Okay, see, absolutely correct. The thing about a black hole or a neutron star is, one, first of all, it has to be a huge, massive star. Okay, yesterday we discussed the Chandrasekhar limit. We said the option is C. That is true. We discussed the Chandrasekhar limit, and we discussed that the mass of the sun, mass of the star has to be at least 1.4 times the mass of our sun for it to turn into a black hole or a neutron star. Okay. Now the funda is that as and how it ends its life cycle, the star comes to the end of its life. What happens is, because of its large mass, it has a large gravitation attraction. Okay, वो acceleration due to gravity बहुत ज़्यादा होता है surface में. There's a huge gravity attraction acceleration due to gravity on the surface, and because of that, that whole star starts to fall within itself. Okay, and when it is falling within itself, what happens is, since the acceleration due to gravity is so high that even light cannot escape. Even light cannot escape from that particular star, and hence it is called as a black hole, because you can't even see light emitting from it. Okay, so hence the name black hole. All right, okay. So we have to go with the large acceleration due to gravity. It cannot be moderate, it cannot be less, it cannot be okay. The acceleration due to gravity has to be very, very, very high. Okay, because of the mass once again. Sorry, what? Rotation की वजह से? हाँ. नहीं, उसमें नहीं आता है हमको इतना डिफरेंस. थोड़ा सा लगता है, लेकिन दैट यूजुअली वो जो जिसकी आप बात करें, दैट यूजुअली डिपेंड्स अपॉन द प्रिवेलिंग विंड्स. You should not be trying to cross some wind or something like that. Airlines will usually take very good care about it, that they do not travel across the winds. We experienced that a long time ago with jet streams, so we avoid those on a particular like very clearly we avoid those. When you're traveling backwards and forwards now, I think it is just the physics also works that way, right? You're not just, this is what we are feeling. We do not feel the earth rotating, right? So we do not have to how do you say, compensate for the effect of it while traveling from one place to another. वो तो it will affect the wind motion and it will affect this motion of the water and everything, but that is just included in everything else, and it is always balanced, right? Even the wind and the water motion will be balanced. It won't be just in one direction. There will always be a counter current. There will always be a balance to it. The entire universe is going to work like that. There'll always be a balance to it. If something is left unbalanced, unchecked, then that is a problem in the universe. Then what we are doing currently with the environment, that is a problem, right? Oh, okay. The shortest day length that occurs in the northern hemisphere is on. Northern hemisphere का shortest day कौन सा होगा? Which is the shortest day in any hemisphere? The winter solstice. Okay, that is going to be the winter solstice. So when do we celebrate our winter solstice? 22nd December. Absolutely correct. Winter solstice is going to be the shortest day. Northern hemisphere way, winter solstice is going to be the shortest day anywhere in any hemisphere. Okay, but depends. Like our winter solstice is in December. In northern hemisphere, the winter solstice is in December. In southern hemisphere, the winter solstice is in June. So clearly, they are experiencing the shortest day in June. Southern hemisphere is experiencing the shortest day in June, whereas we experience the shortest day on 22nd December. Okay, and longest day on 21st June when we experience summer solstice. Okay. Coriolis effect is a result of the pressure gradient, the Earth's axis of inclination, the Earth's rotation, Earth's revolution. 22nd December. It shouldn't be 22nd. Second, let me clear the doubt there. Shortest day length will occur on. No, I'm saying that we are saying that the shortest day length will happen in any hemisphere on the winter solstice that hemisphere celebrates. Okay. So for us, our winter solstice is 22nd December. So it is the smallest day length, shortest day length. Okay. Whereas contrast that with the southern hemisphere, on the same day, they have summer solstice. So clearly they are having the longest day there. I was contrasting the northern and the southern hemispheres. Okay, you are saying this is Earth's rotation. Very good. What is pressure gradient, people? What is a gradient? A gradient is a flow. Okay, right? There is a difference. There is a difference and hence the flow. So there is a high pressure, there is a low pressure, and then hence hence the air flows from a high pressure region to a low pressure region, and that would be called as the pressure gradient. Okay, so this is how planetary winds vagare flow. That is exactly the reason how planetary winds flow. Earth's axis of inclination is the tilt. And then the tilt is already responsible for the seasons, the varying lengths of day and night, the altitude of the midday sun. That is all coming from the Earth's axis of inclination. Okay. Earth's rotation is responsible for the Coriolis force because the Earth will rotate at different speeds at different latitudes. All right. And Earth's revolution is responsible for giving us a year and seasons, maybe. Year is the thing. Okay. All right. During the solar eclipse, the Earth comes in between the sun and moon. The moon comes in between the sun and Earth. The moon comes exactly halfway between the Earth and sun. The sun comes in between the Earth and moon. B, very correct. We are saying we are on Earth. Okay, there is that sun over there. All right. I was watching the sun. Now I cannot watch the sun. What has come in the middle? The moon. So obviously it is the sun, the moon, and then the Earth. Okay, the moon has come between the sun and the Earth. Does the moon have to come exactly halfway? Is it possible for the moon to come exactly halfway between the sun and the Earth? No, the moon is orbiting the Earth. Okay, it is never going to cover that distance. Halfway kahan jayega wo apna orbit chhod ke? Where is it going to go halfway to the sun? Right? Don't choose that answer. One student of mine did that. Okay. Then this one, which of the following statements in the context of northern hemisphere are correct? Now we are specifically talking about the northern hemisphere. The options are vernal equinox occurs on March 21. Vernal equinox is spring equinox. Does it occur on March 21? Yes, we do have it. When do we celebrate equinoxes? In March and September. 23rd September, 21st March are the equinoxes. One is the vernal equinox, the other is the autumnal equinox. And when do we celebrate our solstices? June, when it is normally summer everywhere, so we celebrate the summer solstice. And in December, we celebrate the winter solstice. Okay. So we are saying the vernal equinox definitely happens on March 21. Does summer solstice occur on December 22? No. Does autumnal equinox occur on September 23? Oh, yes. Does winter solstice occur on June 21? No. Not in the case of northern hemisphere. This will ring true in the case of southern hemisphere, not in northern hemisphere, right? So we'll go with options 1 and 2. Very good. Option B. ये लास्ट है क्या? हाँ जी लास्ट है. According to the geoscientists, the shape of the Earth is round, spherical, close to that of sphere, oblate, ellipsoid. See, people, look at how the answers are posed and what options you have for it. You know for sure that this is the correct answer. This is the most correct, technically correct answer. Okay. So wherever 4 is, mark those options. These are the two options from which you get. Oblate ellipsoid is correct. Can you call it spherical? No, you cannot call it spherical. So maximum the maximum stretch you can make is you can call it close to that of sphere. Okay. So we'll go with 4, 3, and 4. So we are going with this option. Okay. If you are ever in doubt, and anyways in general, check the options given. So you, if there was ever any doubt in your mind, it will be cleared by whatever options there were. Okay. Okay. I said this is there. Okay. Do you wish to take a 2-3 minute break? Yeah. I will begin in exactly 5 minutes. It is 53 now. I'll begin at 58. Huh? No, no. I'll begin in exactly. Acha, go 6 minutes. Go quickly. The kids just went out for a break. They are having a break now. हाँ, it's a break. 5 मिनट का break दिया because 3 घंटे का lecture है तो कहाँ. Three. I can't afford to do that, Baba. अच्छा आपकी घड़ी में नहीं I went by clock. Okay, I'll begin. Anyways, the next thing that we are starting out is the structure of the earth and the endogenic processes. Okay, when we talk about the structure of the earth, we are saying ki we are going to discuss the different layers of the earth, and we are going to check out what makes those layers special. We are going to look at the interior of the earth very briefly. We are going to look at the various specific characteristics of all the layers of the earth, and we are also going to try to discontinuities that lie within the layers of the earth. Okay, fine. That is what we are going to look at. Then the next thing that we do is we are going to look at the theories for, there are four different theories for the formation of oceans and continents. We are going to look at that. Okay. So one is an obsolete one, the other is, but it is the basis for everything, continental drift theory. And the one is the most recent one, tectonic plate theory. So we are going to discuss those theories and then two more processes with it. The next part of which we are going to do just half of it is going to be geomorphic processes, of which we'll only do endogenic processes. And geo meaning earth, morph meaning change. So we are saying that the surface of the earth keeps changing due to different processes. Whether in one case the forces can come within the surface from within the earth, and in other case the forces that change the surface of the earth can come from outside the earth. Okay, so when the forces are coming from within the earth, we call that as an endogenic. We call that endogenic processes. When the forces that change the surface of the earth come from outside, like wind and rain and all that sort of thing, then we call that exogenic forces. Okay, so in this particular chapter, we'll only deal with endogenic process, endogenic movement, endogenic processes and all. Okay, this is what you're going to do. So now we go forward and study the structure and interior of the earth. Okay, Earth has a layered structure. We all agree to that, okay? Just yesterday, we had checked out how the planet is formed. We said that originally it was in a hot dense state, okay? And then over the period of time, over the course of time, it started to cool down, okay? As in how it was cooling down, matter got distributed differently, and similar matter got attracted towards each other. That was the cohesion. And then there was accretion, matter started to accumulate, and then it started to accretion and accumulation, and finally you got that planet. Okay, now while the planet was being formed, you have to understand that while the matter was being condensed, the heavier material, so the heavier matter went and sank at the core of the earth. Okay, it went and sank to the core. It went and did that. Okay, and then the middle layers were less dense, and then the layers above at the very surface of the earth were the least dense. Okay, so depending on the depending on the differences in density, the matter settled. Okay, the earth got differentiated into layers because of the differences in density. Okay, because there was a difference in density, hence the more denser materials accumulated in the core and the less denser materials accumulated at the surface of the earth. Okay, okay. So uski wajah se basically you will have these different layers. Now which are these layers that we know of? We know them as the core, which is at the No, that is atmosphere. This we are discussing the layers of the earth, the interior of the earth. Okay. Core mantle crust. Okay, we are talking of that. The core happens to be the one that is the densest and which lies very close to the center of the earth. Okay, so we are talking about this particular layer, the core which lies at the center of the earth. Okay, that happens to be the densest of all layers. All right, and then you come to the mantle, which is a little less dense than the core. Okay, so mantle happens because it is not concentrated at the center. You can assume that it is less dense than the core. Okay, so this is the mantle, and the uppermost layer, which is supposed to have the least density, is going to be the crust. Okay, so this is the crust that we are talking about. That is going to be the layer with the least density. Okay, in another way, in another terminology, we will call the crust as the lithosphere. Okay, the crust can also be it is not technically correct, but in most cases we can refer to the crust and the lithosphere as one and the same thing. Okay. Once again, I'm reminding you, it is not technically correct, but we can use this terminology as well, that the uppermost layer is called as the lithosphere. Then the layer in the middle, this particular layer, right? This layer is called as the mesosphere. The mantle is called as the mesosphere. The part of the mantle is called as the mesosphere. And the core wala jo layer hai, the layer where the core lies, is called as the barysphere. Okay. So this is another way of referring to these different layers. But this is what we are looking at. We are either calling them core, mantle, and crust, or then we are calling them barysphere, mesosphere, and lithosphere. Okay. The lithosphere is a little different thing, but we can still look at that. All right. Have you noticed that between these layers, clearly there is a difference in density, right? Between the different layers, there is a difference in density. Even within the core, if you see with the core, there is an outer core and inner core. Why do you think that difference is? Because there is a difference in density. Okay. The outer core will be a little less dense. The inner core will be more dense. Okay. So clearly there also you will find a density difference. Here also, within the mantle also, the upper mantle has a different density, lesser density, whereas the lower mantle has more density. Okay. So within the layer of a mantle or within the layer of a core also, you will find that differentiation. Okay. And wherever this density changes, you will find a discontinuity. Okay. When we are talking of a discontinuity, we are talking of this, where the layer changes. Okay. Whether it is within the layer or whether it is between two different layers, say with the core and the mantle. So this is the difference between the core and the mantle. Okay. So you will have a discontinuity here. Even within the mantle, when where there is a transition between the upper mantle and the lower mantle, where the density differences, where the density changes, you will have a discontinuity. A discontinuity is a transition layer. Okay, it will transition from one layer to another. So discontinuity is a transition line from where it goes from one layer to another layer. It is called as a discontinuity because, say, suppose the seismic waves were moving about in this particular layer. Okay, so they are moving at a certain speed in this layer. Okay, now they come to this transition point and they move on to the lower mantle. Okay, this is what we are considering. Say the seismic waves are now moving from one layer to another. Their behavior will change, their speed will change. Okay, please remember, seismic waves will always be faster in denser mediums. It is not the same as normal solid materials. You will always remember that seismic waves will always be a little faster in denser mediums as opposed to the less denser mediums. Okay, okay. So because the behavior of the wave alters, because the behavior of the seismic wave alters, we call this particular transition line as a discontinuity, because the earlier behavior is discontinued and then the wave starts behaving differently in the next layer. Why? Because the density changes. Are we clear? The layers exist because there are differences in density, and because there are differences in density, wherever that density changes between layers, you will find a discontinuity. Okay, and we will properly name all these discontinuities. We are very happy to name these discontinuities and keep on revising them in every paper. Every time UPSC keeps asking you about these discontinuities, so we are going to look at them. Okay, are we good here, people? Huh? Samjha? Now let's try to look at these discontinuities. Okay, the first discontinuity that you see is the Conrad discontinuity. Okay, it lies within the crust, between the upper crust and lower crust, rather between the Sial and the Sima. Okay, that is where the first discontinuity lies. It is called as the Conrad discontinuity. Okay, I'll give you a satta to remember the names of the discontinuities. Okay, next is the Mohos discontinuity. It is also called as the Mohorovičić discontinuity because the name of the scientist was कॉन्राड इज बिटवीन सियाल एंड सीमा. उन्होंने दिखाया नहीं आपको अच्छे से, लेकिन ये जो कॉन्टिनेंटल क्रस्ट है ना, दैट इज सपोज टू बी सियाल, एंड वो जो ओशानिक क्रस्ट है, इट इज सपोज टू बी सीमा. बट वो transitions होना चाहिए, and they should basically be an oceanic crust to tell कि yeah, this is the continental and this is the oceanic. So Conrad discontinuity basically lies between the Sial and the Sima. It lies within the crust between the Sial and the Sima. You will find the Conrad discontinuity. Okay. Then you find the Mohos discontinuity. Can you make out the Mohos discontinuity? Name of the guy after whom this discontinuity is named is Mohorovičić. Okay. Russian Slavic ancestry, I'm assuming. So we are saying कि Mohorovičić जो बंदा था उनके नाम के पीछे ये मोहस डिसकंटिन्यूटी बोला. मोहस किसके बीच में लाई करता है? इट लाइज बिटवीन द क्रस्ट एंड द मैंटल. ओके, mohos lies between the crust and the mantle. Okay, next you see upper mantle, lower mantle will also have a difference, right? So you will get a discontinuity there too. There the discontinuity is called repeti, an Italian geographer. तो उनके नाम के पीछे उसको नेम किया था repeti discontinuity. Okay. Then again, when the layers change from the mantle to the core, you will again find a discontinuity. That particular discontinuity is called as Gutenberg. Okay, the spelling is wrong here, but the discontinuity is called as Gutenberg. Okay, Gutenberg like the place Gutenberg. Yeah, so that is the Gutenberg discontinuity. And then between the outer core and the inner core, again you find another discontinuity, which is called as the Lemons discontinuity. Okay, Lemon is another name of a person, so Lemons discontinuity. Are we good here? If you want to remember all the discontinuities in one go, this is the satta. Chief ministers are, I'm writing are the way you guys do, great leaders. Okay, chief ministers are great leaders is the satta for remembering discontinuities from the top to the bottom. C stands for Conrad. Chief का C stands for Conrad. M stands for Mohorovičić. R for Repeti. G for Gutenberg. And L for Lemon. Okay. So these are those 5 different discontinuities. So from the beginning to the top. Conrad कहाँ lie करेगा? Within the crust. Sial ऊपर, Sima नीचे. I should say once more. Chief ministers are great leaders. You can see this discontinuity. You cannot see Conrad. Conrad is over here. Okay, it lies within the crust between the Sial and the Sima. कौन है? कोई तो जाके बताइए ना उस क्लास में कि थोड़ी कम आवाज करे. एंड अगर वो नहीं सुनते होंगे, कोई टीचर नहीं होंगे, तो प्लीज फरहाना मैम को या किसी को रिसेप्शन पे बताइए. I don't mind a little fun, but this is crazy. Okay. So chief ministers are great leaders. C stands for Conrad. It will lie within the crust. It lies between Sial and Sima, the layers of the crust. Hi. एक student है. You, which standard are you in? 11th. Okay. We are discussing, sit down. We are discussing 11th. No, we are not discussing 11th standard. What am I saying? We are discussing NDA geography, the one that is required for the NDA exam. It would do well if you listen, if you are planning to give the NDA exams. Are you? Okay, yes. Then this is exactly the same thing that you are going to learn there. Okay, just pay attention. If you need something, if you do not understand something, ask me. No problem. What's your name again? Kriti. Kritika. Okay. All right. So once again, back to our discontinuities. Chief ministers are great leaders. C stands for Conrad. Conrad is the discontinuity at the very top. It lies within the crust. It lies between Sial and Sima. Okay. Then next, M minister. M stands for Mohos or Mohorovičić discontinuity. It lies between the crust and the mantle. Okay. That discontinuity lies between the crust and the mantle over here. Okay. This is where the discontinuity is. Next, R. R stands for Repeti. हाँ उनको बिठा दिया है यहाँ पे. ये 5 बजे तक बैठेंगे मैम, तो you are locked until 5 now. That is not my bad answer. This is Repeti. Repeti is between upper and lower mantle. Okay, Repeti is between upper and lower mantle. And then great ka G stands for Gutenberg. Okay, that is between the mantle and the core. That is between the mantle and the core. And lastly, you have L for Lemon. Lemon stands for discontinuity between outer and inner core. Okay, are we good here? Please remember this. Okay. ये सट्टा अच्छा है. You understand what discontinuities are. You understand why the layers were differentiated because of the differences in density. Hence, you get multiple layers. And within these layers also, there will be multiple distinctions between density. And hence, you will get those different discontinuities. Okay. So those 5 discontinuities you need to remember from the top to the bottom. Sometimes UPSC poses questions as which is the discontinuity between these 2 certain layers. Or sometimes they simply ask you which is the discontinuity which is closer to the center of the earth, or least or farthest away from the center of the earth. So you need to know which this discontinuity is. Okay, it can either be Conrad or it can be Levens, right? All right, now you move on to the actual structure of the actual layers. Each of these layers, we look at the crust first. See, can you make it out? Can you make out the text in pink? I had put it in pink. Okay, good. Because from my angle, I really can't see it very well. Okay, so the first particular layer that we are looking at is the crust. Okay, crust जो होता है, it extends up to 100 kilometers. Okay, so it can be anywhere between 0 to 100 kilometers. You can have very little crust or a very thin crust, or you can have very thick crust. Okay, for example, in places like the Himalayas or places where things have been very stable for a very long time, you will find that the crust has thickened. It has thickened a lot. Okay, Himalayas में clearly जितना ऊपर folding है उतना नीचे से भी distortion है. So clearly over there you will find that the crust is pretty thick. Okay, but there are places where the crust can be really thin. So the crust will vary. That how do you say, the thickness of the crust will vary from anywhere between 0 to 100 kilometers. Okay, it is brittle in nature. This you got to remember, that the crust is brittle in nature, and normally you differentiate between the upper Sial and the lower Seam. Okay, the continental crust is called as the Sial and the oceanic crust is called as the Seema. The reason why we are differentiating them between the continental and the oceanic crust is because continental crust, meaning it is made up of different materials basically. So continental crust is made up of silica and aluminium. Okay, see here we are talking about silica and aluminium. So continental crust is basically made up of that, whereas oceanic crust is made up of silica and magnesium. So once again, you will find a difference in densities, and now you understand why that Conrad discontinuity actually exists over there, because there is a difference in densities. Okay, okay. So let's look at the Sial. Sial is made up of, the name itself says it is a silica and aluminium. Okay, it is continental crust, mostly granitic rock. It is mostly made up of granitic rock, and it is less dense, 2.7 gram per centimeter cube. It is thicker. On an average, the thickness is 30 kilometers. Okay, generally it is considered as thicker because it stays for a long time. It is also older. It stays for a long time. So continental crust is considered thicker also. Okay. On the other hand, Seema जो होता है, that is made up of silica and magnesium. Okay, it is oceanic crust. It is mostly made up of basaltic rock. Okay, because this is lava upwelling, lava being formed, lava being pulled very quickly underneath the water. So clearly that will be basaltic rock. Okay, we are talking of that rock. It is usually denser than the Sial. The density is around 3 gram per centimeter cube, and it is thinner. The average thickness is 5 kilometers. Okay, once again, the reason being, we see that in the ahead in the chapter, that this oceanic crust is constantly being recycled. It is made and then it is destroyed. It is being made, it is being destroyed. Okay, so this constantly keeps on happening. So it never gets the opportunity to sit for a long time, accumulate more thickness, and be more thick and all. This is how it works with oceanic crust. It is constantly being made, created, and constantly being destroyed. Okay, so this particular oceanic crust is usually going to be thinner. This meaning oceanic crust is generally thinner. Average thickness 5 kilometers. Okay, are we good here? Please remember this data very well. UPSC has asked you questions on this data at least 3 times as per my knowledge now. Even this time, the April exam, the one that they had in April, they asked you questions based on this. See, which is thinner, which is thicker, how much is the thickness. So this data is very important. It comes directly from an NCERT book. Okay, so please remember the data. All right, next. Mantle. Now you come to mantle. Mantle starts from, this is most discontinuity over here. So mantle starts from most discontinuity and it is up to over here. Okay. Mantle को जरा ठीक से note कीजिए. This is the actual mantle, right? This much is the actual mantle. Okay. Now this upper mantle, let's divide it into 3 parts. The first part is the uppermost solid mantle, the one that I have crisscrossed. Okay. This is the uppermost solid mantle. All right. It is solid, meaning it is proper solid, and the uppermost part, so we call it the uppermost solid mantle. Okay. The next part over here is called as asthenosphere. Okay, this is the fluid molten portion. This is where all the magma in the world comes from. Okay, this is all molten magma, and all the magma in the world for all available, for all volcanic activities ever comes from this particular place. Okay, asthenosphere. So asthenosphere is that molten part. Okay, so what you are essentially having within the upper mantle is that you have an uppermost solid mantle. Below that, you have a fluid, asthenosphere section, a molten asthenosphere section, and then you have the semi-solid upper mantle. Okay, the rest of the semi-solid upper mantle exists beneath the asthenosphere. Are we good here? These are the three sections. All right. So now, even within this part, we are saying that this little part, this uppermost solid mantle, and the rest of the crust together, that will be called as the lithosphere. Got it? This is also another question that UPSC keeps on continuously asking you, that what is a lithosphere? It is the crust and the uppermost solid mantle. Okay, it will take a little section of the mantle and the entire crust, and together these two will be called as the lithosphere. Okay, and this entire lithosphere is floating on one molten body, which is that the asthenosphere. Okay, the layer of the asthenosphere, which is molten, that entire lithosphere is floating upon it, nicely floating upon it, because it is molten. So clearly that solid structure, the crust and the uppermost solid mantle, the solid structure can float easily upon the asthenosphere. Okay, are we good here, people? Samjha ye? So we are saying that this lithosphere is the uppermost mantle and the uh, is the uppermost mantle and the this what do you say crust. Okay, so lithosphere is the crust and the uppermost solid mantle. We are saying lithosphere is the crust and the uppermost solid mantle. Olivine is the major component in mantle is, like I said, semi-solid state hoti hai wo thodi si, and this is the component that you usually find in it. Okay, olivine, just like we had Cl was made up of silica and aluminium, Sema was made up of silica and magnesium. So mantle is usually made up of olivine. Okay, and this is the asthenosphere once again is important because it is the source of all magma. Okay, this is where all the magma in the world is sourced from. So asthenosphere is important. Please remember, will you remember these three parts of the mantle? Upper mantle, you're saying that there is an uppermost solid mantle with together with the crust, which will be called as the lithosphere. Then there is the asthenosphere upon which that entire lithosphere is floating, and the asthenosphere is clearly molten. And then there is the semi-solid upper mantle. Okay, okay. Moving on to the core. Okay, now this is the core. This section, that section and downwards over here, that is the core. Okay, it extends from the Gutenberg discontinuity to up to 6,400 kilometers. We normally generally roughly say that the radius of the earth is about 64, I think 6317 or something is the exact 6,371. 6,371 is the exact radius, and we say approximately 6,400 kilometers. Okay, it is made up of Ni as in nickel and iron. Okay, so that will be Ni. It is made up of Ni. The density at the mantle, this is the mantle core boundary. Okay, so the density at the mantle core boundary is 5 gram per centimeter cube, and by the time you reach the core, the center, the density becomes 13 gram per centimeter cube. So clearly, core is very much dense. Okay, now you have to remember one very interesting thing about the core, that the inner core is solid and the outer core is liquid. Okay, normally you assume that if there is so much pressure acting upon a body, then the 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 part at the center of it, the inner core, should ideally have been in a liquid state. Okay, but because बहुत ज़्यादा pressure act कर रहा है ना, so solid will turn into liquid, under so much pressure. But that does not happen in this case. The reason being that the core is made up of very dense materials. Okay, so because of the extreme density, it can never be really converted into a liquid state. Okay, but what does get converted into a liquid state is the outer core, where the materials are a little less denser than the inner core. Okay, so the outer core is liquid, the inner core is proper solid. Okay, will you remember this? Yeah, the outer core is liquid, inner core is solid, right? So this you got to remember, and please remember all of these things, because you do get asked questions 100 times over this. मैंने बहुत questions देखे हैं इसके ऊपर. So please pay attention to these different discontinuities, the different layers, what these layers contain, asthenosphere, lithosphere. 100 times they've been asking you these questions. Okay, since ever they've been asking you these questions. So please pay attention. Okay. Now we go to theories of formation of oceans and continents. We say that the way the earth looks right now, okay, that there are continents and there are oceans spread around and all, this particular formation, how did it come to be? Okay, so for that we have different theories. The first being continental drift theory by Alfred Wegener. That was proposed way back in 1912. And then in 1930, Arthur Holmes gave a proper mechanism to it. Like he did not say that there is a theory for the, the formation of continents and oceans. He gave you the mechanism behind it. What is the moving force? Okay. And that was given by Arthur Holmes. That is called as the convectional current theory. Okay. This is a very important theory. Then you come to 1961 and you get Harry Hess went and proposed the seafloor spreading theory. Okay, so that is also another important theory in this entire process. And lastly, you have the tectonic plate theory. It was proposed by multiple people. I'm just naming three of them: Mackenzie, Parker, Morgan. Okay, so in 1967, this particular theory was proposed. We go with this particular theory now. Okay, this is the standard, widely accepted. Most scientific community will accept this particular theory. Okay, the tectonic plate theory. Let's start with the continental drift theory. We've read about the continental drift theory, right? You have Alfred Wegener. Alfred what? Who's Alfred Stuyvesant? I don't know about this particular person. Maybe I know about Alfred Wegener, who proposed this particular theory. We can look into who Alfred Stuyvesant is, but we are looking for Alfred Wegener. Okay, Alfred Wegener in 1912 he proposed this particular theory. Now this is where he started. People, when he proposed the theory, what the general idea of the theory was correct. What he said was correct. This is how the process happened. Okay, there was a supercontinent, there was a super ocean, then the continents started breaking, and the continents and it started moving away from each other. Okay, until here he was correct. Whatever evidences he proposed for this particular theory, it's related to biology. Okay, good. Then we do not have much concern over here. It can be still a useful thing, because we don't know if that guy ever contributed to this particular study, right? I have really never heard of that person. And then lastly, whatever evidence he gave in favor of this theory was also extremely correct. Okay, what he went wrong about in this particular theory was why that drift was happening, why the continents were moving from place to place. He just went wrong there. He couldn't name the particular reason why the continents were moving. Whatever reasons he gave were incorrect. Okay, the forces were not large enough to move the continents. But he was obviously wrong about that. About everything else, he was absolutely bang on correct. Okay, right on the money. Are we good, you people? Huh? Let's understand the theory now. This guy proposed, Alfred Wegener said that before everything started looking the way it does, there was a huge supercontinent. All the continents, all the land in the world was together. Okay, it was one contiguous piece of land, and that was one supercontinent which we called as the Pangea. Okay, and then it was surrounded by an ocean, a huge super ocean, which we called as the Panthalsa. Very correct. Okay, then in Mesozoic era, that Pangea started to split up. तो वो जो नॉर्दर्न पोर्शन था वो बना लॉरेशिया, एंड वो जो सदर्न पोर्शन था दैट बिकेम गोंडवाना लैंड. ओके, एंड उसके बीच में जो सी एग्जिस्ट करता था दैट वाज कॉल्ड एज द सी ऑफ टेथिस. वेरी करेक्ट. ओके, एंड देन धीरे धीरे लॉरेशिया आल्सो स्टार्टेड ब्रेकिंग अप, गोंडवाना लैंड आल्सो स्टार्टेड ब्रेकिंग अप, एंड दे ऑल स्टार्टेड ड्रिफ्टिंग अवे फ्रॉम ईच अदर. ओके, इट स्टार्टेड ब्रेकिंग इनटू मल्टीपल पीसेस and started drifting everywhere else. Okay, now this is what he proposed as the mechanism why these pieces were drifting away from each other. The mechanism for that, he said that the movement happens in two places. One, either it will go westwards or it will go equatorwards. Okay, this is where the continents were moving, and the reasons he said, the forces involved, he said, was if it was moving westwards, then it was the tidal force, the gravitational attraction between the moon and the earth and all. He said that is making it happen, that is making the continents being pulled and pushed apart. And then for the equatorward force, the polar flame force, he said that it is going to be the centrifugal force, because the earth is rotating, so the centrifugal force exists, and because of that the pull is towards the equator. Okay, so you feel that it is fleeing from the pole and coming towards the equator, and that is the motion of the continents. That is what he was saying. Okay, he was very, very wrong about this, but other than that, he was everything else that he proposed was absolutely correct. Okay, and you will see the evidence now. The evidence for the continental drift theory was that, first of all, if you ever see Africa and South America, see this part, look at this particular part and look at this particular part. Don't you think they fit together like a puzzle? Yeah, it absolutely fits like a puzzle. So clearly they used to be together once and then they broke off and went away, because of which you can see where they broke off also, right? Clearly, if I try to bring these two pieces together, these two pieces together, this shoulder of Brazil is going to fit in this particular nook, right? It is going to fit perfectly into that nook. So we are saying that this fits like a jigsaw puzzle. ये जो coastlines है, South America के and Western Africa के, they clearly match. Okay, even the rocks on these coastlines are same of age. Okay, they are of the same age, they are of the same type. Sometimes you find that you will find gold deposits in Ghana and you will find gold deposits in Brazil, but Ghana doesn't have any source rock. वो जो लोड होता है, गोल्ड का ओरिजिनल लोड होता है, वो तो वहां नहीं मिलता है, वो तो आपको सिर्फ ब्राजील में मिलता है. Okay, so this was also another thing he said, that this is unusual for it. Okay, one second, huh? This, according to him, this was pretty unusual. Okay, and then there is also one particular rock called as tillite. Okay, tillite करके glacial sedimentary rock मिलता है, and that you find in almost all the land masses in southern hemisphere and in India. Okay, which means कि India used to be at some time, it used to be in the southern hemisphere. Okay, that is what it says. Once again, you will find that Atlantic Ocean में जो marine deposits है, whatever marine deposits you find in the Atlantic Ocean, they do not predate the Jurassic period. Okay, you will not find any marine deposits before the Jurassic era. Okay, so clearly the Atlantic Ocean did not exist before that time. So if the Atlantic Ocean did not exist, clearly there was just land over there, no water. Okay, that is what we say. Then sometimes you find that this is Norway. Can you see where Norway is? This is Norway over here. This is Norway. Okay, this particular portion, yellowish country that we are watching, that is Norway. Okay, now this country has fossils for tropical plants. Okay, now look at where that country is. It is a frigid area. Okay, and it has fossils for tropical plants, which means that clearly tropics cannot be at that part. So clearly the country has to be somewhere in the tropical zone. Okay, so at some point of time, the country was somewhere in the tropical zone. Those tropical plants existed over there. They lived and died over there. They became fossilized. And meanwhile, the country or that particular part of the continent moved away right where it is. Okay, that is the theory that was proposed. Then the next thing is that distribution of identical fossils across. Now, this particular diagram is for that. You see these different creatures, Synagnothus, या Mesosaurus, या फिर what is this Lystrosaurus वगैरह. These are different creatures. Okay, so we are seeing all these creatures. You will find their fossils distributed all over these regions. Okay, almost all over southern hemisphere and India. Okay, even there is a plant fossil called as a Glossopteris plant. So you will find it's a kind of a fern. So you find the fossils of that particular plant also in all the land masses of the southern hemisphere and India, which clearly means that sometime India used to be somewhere in the southern hemisphere rather than where it is now. Okay, in the northern hemisphere. So India was clearly over there. And more importantly, this particular theory, continental drift theory, it debunked the evidence of two important mythical places. One is Lemuria, the other is Kumarikandam. They are synonymous to each other. Let's try to understand what Lemuria and Kumarikandam are. Lemurs used to be a kind of a creature. Okay, so we say the fossils for these particular creatures are found in here and here, only these two places in the world. Okay, so we say that the fossils for lemurs were found only in India and in Madagascar. Okay, so most people used to say that this entire piece of land was joined. Okay, it was a proper contiguous piece of land, and so the lemurs could move from place to place. Okay, and that is why you will find fossils in both these places. And then this beach ka land, ye jo beach ka land hai na, that sunk. Okay, it went and submerged inside the sea, and that is why you do not see the land now. All you see is one Madagascar and one India. Okay, that is what people used to say. And this particular land was called as Lemuria because of the presence of the lemurs, or then it used to be called as Kumarikandam. In Tamil literature, it is referred to as Kumarikandam. Okay, this particular land. Now, this does not only include this, it also includes that Adams Bridge and everything. So, wo bhi kisse aa jate hai. But this was that mythical piece of land. It was called as Kumarikandam or Lemuria. Now, once the continental drift theory was proposed, clearly you understood that since the continents are moving away, clearly there is no land that is submerged and it is lost and something of the sort. Okay, so clearly there never was a Lemuria or a Kumarikandam. It was simply that the land used to be together at one point of time. It split up and moved away. Okay, that is exactly what happened. Right, so it debunked these two theories. Continental drift theory is very instrumental in debunking these two theories. All right, okay. But remember, despite all the evidence that he gave and despite all the correct assumptions he made, he was very wrong on the forces that move the continents. Okay, who gave us the right idea about the forces? That would be Mr. Arthur Holmes. Okay, Mr. Arthur Holmes, who proposed the convectional current theory, gave us the very correct idea on what is making these continents move. Okay, remember, मैंने आपसे क्या कहा था that there is the crust and then there is the uppermost solid mantle, and these two together make up the lithosphere. Okay, and what is the lithosphere floating on? Asthenosphere. Okay, the lithosphere is floating on the asthenosphere. Now, this asthenosphere is this part of the mantle. Okay, we are saying this is this part of the mantle, right? That is the mantle part. Okay, and then this is the core. This here begins the core. Now, do you understand? You have to try to understand. One, first of all, when the earth was being formed, it retained its own heat, right? That is called as the primordial heat. The heat of its origin, it kept on retaining it within itself. Okay, so there is already the primordial heat over here in the core. Okay, ऊपर से all those radioactive materials have also gone in over there, right? All the heavier, denser radioactive materials have also gone and settled in the core. So those radioactive decay keeps on happening. If the radioactive decay is happening, clearly energy is being released and the core is becoming really hot and hot and hot. Okay. So this temperature, this particular temperature is clearly hot. Okay, the temperature towards the lower part of the mantle, because of the proximity to the core, it is clearly hot. What happens to the upper part of the mantle? Clearly the temperatures are not very high over there. Okay, they are not as high as the lower part of the mantle. Okay, so now there is a temperature difference within the mantle. You can clearly see that the upper part of the mantle has a lesser temperature. The lower part of the mantle has a higher temperature. Okay, and because of that, convectional currents are set up. Okay. Let's see what conventional currents are. This is what we are looking at when we say conventional currents. You see, if we keep a beaker of water, okay, and we put in two wooden blocks in it. Can you see these two wooden blocks over here? Yeah. Is that not gone? It is gone now. Okay. So if we keep two wooden blocks over here and we light the stove from down. Okay. We light the stove and then we let the water boil. Okay. In a while, the water starts to heat up. Which part will get heated up quickly? The lower one. Okay, so what happens from there? The water becomes lighter and rises upward. Okay, where it is going to rise? It is going to rise from the middle. Here it is going to rise. Okay, it is going to rise here in the middle, and then it is going to travel sidewards. Okay, and then it is again going to travel downwards because now the denser, heavier water is going to settle down over there. Okay, and then this motion is completed like this. Got it? This is the motion that is completed, right? Why? Because there are temperature differences between the layers. Within this beaker, you will find that the lower layer is hotter, the upper layer is colder. So clearly, the water from the lower layer is going to rise upwards, travel sidewards, fall downwards, and then again meet over here. Okay, so these are called as convectional currents. And how do you know that these convectional currents are set up? These wooden blocks are being pushed in this direction. Okay, that is why you know that these convectional, because you can't clearly see currents in the water, right? But you know that the wooden blocks are clearly being pushed in opposite directions. So you know that these currents are being set up. Similarly, a very similar process happens in the mantle also. Okay, this part of the mantle is extremely hot. Okay, this part not so much. Okay, the upper part of the mantle not so much. The lower part very much high. Okay, very much hot. So what will happen is green color. Okay, so what will happen is this is the kind of convectional current that is set up over here. Okay, do you get that? And this is the type of convectional current which is set up in the mantle. And because these convectional currents are set up in the mantle, they will also influence the asthenosphere. Okay, and if the asthenosphere is moving, clearly what else is moving above with it? The lithosphere, right? So the lithosphere, the pieces of the lithosphere, the lithospheric plates keep moving because of these currents which are set up in the mantle and the asthenosphere. Are we good? This is the force behind moving. When we say that the continents are moving, that there is a drift, this is the force behind it. Okay, that these convectional currents which are set up in the mantle because of the temperature differences keep pushing and pulling and these plates away from each other or towards each other. Okay, are we good? People, are we absolutely good on this? कोई डाउट होगा तो मुझे बताइए, मैं दोबारा एक्सप्लेन कर देती हूँ because इसके आगे फिर then it becomes difficult. Okay, all right. The next theory that now we have established that the continents move. We have also established why they move. Okay, so far by 1930 we have that explanation, but we did not have a lot of idea about what is happening in the oceanic floor. Okay, Mr. Harry has solved that problem for us. He went and proposed the seafloor spreading theory. Okay, and क्या अभी plaid shirt at the back. And your friend. You stopped talking the moment I said AR. So you got the gist, na? Do not talk. Yeah. So seafloor spreading theory. Okay, we are looking at that. We are going to look at how the seafloor spreads. Okay, this is what the theory explains. So we say, look at this particular part. Okay, we are looking at this particular part. You say this is the lithosphere. This entire thing is the lithosphere. Okay, this is the mantle where the convectional currents are being set up. You can see that the direction of the current is like this. Okay, this is the direction of the current. The convectional currents are working like this. All right. And what is happening is that where the convectional currents do match up in the middle, where they find that cell, there will be multiple such cells, right? There will be multiple such cells for convectional currents. Where they match up over here, they will start to push against the lithosphere. Okay, where these currents match up, they will start to push against this part at that particular lithosphere, and it will try to fracture it. Okay, it will try to make a vent through it, it will try to fracture it, it will try to break through that part. Okay, so what happens is this new lava goes and wedges in between here, and it pushes these plates away. Okay, it will try to push these plates away from each other. It will break them and it will push them away. Okay, that is what is happening. And then after a while, this lava is going to cool down. Now, this is all happening underwater, right? This is everything is happening in real time underwater. So when that lava cools down, it will cool down immediately. The moment it comes in contact with water, it starts cooling down. Okay, and it cools down, solidifies, and then it forms a proper basaltic rock, and it will form the new ocean floor. Okay. Meanwhile, this ocean floor, older ocean floor, is being pushed away and is being subducted under some other plate and is being destroyed. Okay, so this is the seafloor spreading theory. It essentially says that new seafloor is constantly being created. It is being created at this point and it is being destroyed at this point. Okay, is this clear? Because of those convectional currents being set up, new oceanic floor is constantly being created and it is constantly being destroyed when it goes into the subduction part. I'll explain what the subduction is, but this is the general idea. Okay, so this is how, and that is why oceanic crust manages to stay so young. Oceanic crust is always considered younger because it is constantly being recreated and destroyed. Okay, that is what is happening with the oceanic crust. And continental crust का ऐसा नहीं है, अगर वो if it remains stable like in the Himalayas or in the Siberian plains or something, if it remains stable for some time, it remains stable, and then the crust keeps on thickening because of deposition and all those processes. Okay, okay, good. That is the theory. Now you come to another important theory. Once again, a huge treasure trove of questions. Okay. यहाँ से आपको this is that box जहाँ से सारे questions उठाते हैं. Tectonic plate theory. Okay. Tectonic plate theory says which is the most acceptable explanation for whatever formation of oceans and continents we have so far. It says let's understand what a tectonic plate is first. Okay. Tectonic plate is actually a lithospheric plate. What is a lithosphere? Lithosphere is, we say, the crust and the uppermost solid mantle. Okay, these two together are going to make the lithosphere. All right, so we say there is a lithospheric plate. It is irregularly shaped, usually very large in size. Okay, it is very large, it is very massive, irregularly shaped rock hota hai wo, and it is solid rock. Okay, why? Because the crust is solid and so is the uppermost solid mantle. Ye sab kuch solid hai. What is it floating over? The asthenosphere. And what state is the asthenosphere in? It is in a molten state. Okay, so it is floating over that asthenosphere. Clearly that, and when the currents are set up in the asthenosphere and the currents are either moving away or pushing things together, clearly the plates above it are also being pushed apart or pulled together. Okay, that is what is happening. So we are saying that these lithospheric plates जो होते हैं या tectonic plates जो होते हैं, they are generally composed of both continental as well as oceanic lithosphere. Okay, do you think oceanic lithosphere is going to be molten or semi-solid or something like that? No, it is going to be very solid. Okay, oceanic floor is still floor and it is still very, very solid. Okay, please remember that. Do not assume that it is just ocean का floor है तो liquid है or anything of that sort. ऐसा नहीं होता है. So both are solid and the plate, lithospheric plate, can either be composed of oceanic crust or continental crust. In most cases, it is composed of both. अगर आप major plates देखेंगे तो all except Pacific come with both a combination of both oceanic as well as continental crust. Okay. अब ये जो plates होती है, they all move horizontally over the asthenosphere. They will either be pulled together, they will either be pushed apart, or they can simply slide by each other. Okay. इस तरह के motions में ये plates move करते हैं over the asthenosphere. Okay. You will find 7 major plates and you've got to learn them by heart. There is no other option for that. Okay. because the questions are usually posed as which of these is not a major plate. Now, if you do not know all the 7 major plates, how can you name the minor plates? You're not expected to know the names of all minor plates, but you're expected to know the names of all 7 major plates so that you can tell which is major, which is minor. Okay, one that is not within major will obviously be a minor plate. Right? Let's count the 7 major plates. We are saying Antarctic, North American, South American, Pacific, Indo-Australian, African, and Eurasian. Okay, let's count them here. नजर आ रहा है? Good. Okay. This is the Eurasian plate. नजर आ रही है आपको? वो जो लाइटर पोर्शन है, ये पूरा ग्रीन कलर का जो प्लेट है ना, this entire green color plate, वो जो पूरा प्लेट है, that is the Eurasian plate. The lighter portion of it is the land, and the darker portion of it, the dark green portion of it, is the water. It is the oceanic crust. Okay, the lighter portion is the continental crust. All right. Okay. So this is the Eurasian plate. Can you see this plate? This plate, which is now this we assume is a goal है ऐसे, it joins ends to end. So ये जो purplish color का नजर आ रहा है, that is the North American plate. Okay. So this is another plate. 2 plates हो गए हमारे. This is the first plate. North American plate is the second plate. Can you see this plate? This is the Pacific plate. Okay. The yellowish color plate, that is the Pacific plate. It is the only major plate which is completely oceanic, which is made up of complete oceanic crust. Okay. Other than that, it is the oceanic lithosphere. Other than that, there is no other major plate that is made up of only oceanic or only continental crust. Okay. Okay. So that is the Pacific plate. Then you have the African plate. Can you make out the African plate over here? Yes. Can you make out the South? Can you make out the South American plate over here? Yes, this is the South American plate. This is the Australian plate along with the Indian plate. So Indo-Australian plate जो है वो ये है. Please remember, if you just consider the Indian plate, it would be considered as a minor plate. If you consider it along with the Australian plate, then it will be the Indo-Australian plate, and that together will form a major plate. Okay. And lastly, here you have the Antarctic plate. Okay. The one below, that is the Antarctic plate. Do you have all 7 major plates? Okay. Please remember, other than the Pacific, all the plates are made up of both oceanic as well as continental crust. Okay. ये आप लोगों को normally कितनी देर तक सोने को मिलता है क्लास में? And I am not being sarcastic. I am seriously asking because you will obviously feel sleepy. But and how much time am I supposed to wake these sleepy heads up? Teachers, बाकी के teachers normally कितने देर में उठा देते हैं? हाँ? ऐसे ही सोने देते हैं? अच्छा फिर ठीक है, तो मैं भी वैसे ही करती हूँ. No worries. नहीं, let them sleep, no problem. Lectures online होते हैं, whatever they've missed you can always find on YouTube, no problem. So here we are. अब ये रहे 7 major plates. अब minor plates ढूंढते हैं. Let's look for minor plates. यहाँ से शुरू करते हैं. Can you see this one? Juan de Fuca. Okay, that is one plate. ये सबसे छोटी plate है अपनी सारी minor plates में से. This is the smallest plate. So Juan de Fuca is one plate. Can you make out this one? Cocos plate. Okay, this is the Cocos plate. Nazca is again a smaller plate. Arabian plate over here, this one, this is also a smaller plate. Indian plate is considered a small plate, a minor plate. Okay, then you move on to, can you see this Filipino वगैरह? वो Filipino plate नजर आ रही है, that is also a small plate. So minor plate. So these are the various minor plates. Once again, I repeat myself. Please remember the names of all 7 major plates, and whatever does not fall in those 7 major plates automatically becomes a minor plate. Okay, ठीक है? You understand what these plates are doing? We are saying that they are lithospheric plates made up of solid material, solid rock, and they are floating over the asthenosphere, which is molten magma. Okay, and the convection currents are being set up in the mantle, which is why the asthenosphere also feels it, and the plates are being pulled along or pushed along the currents. Okay, that is what is causing the drift of the plates. That is causing the plates to move. Okay. Now we look at the various plate boundaries. Like I said, the movement of the plates is basically in 3 ways. You can categorize that in 3 ways. Either the plates are being pulled away from each other, or they're being pushed together, or they're simply sliding alongside each other. Okay, इतने 3 motions मिलते हैं. Being pulled away from each other, being pushed together, or sliding alongside each other. Okay, let's look at this part now. We are looking at when इसको ना different नाम से बुलाते हैं, plate boundaries बुलाते हैं, because plate boundaries are important for us. Oi guys, you're not allowed to talk, huh? I'm not asking you to pay attention. That is up to your discretion. But you cannot talk and disturb the class. You certainly can't talk over me. मुझसे बड़ी आवाज नहीं हो सकती आपकी. नहीं, आपकी आवाज ही नहीं हो सकती. Let's settle there. Okay. Divergent boundaries. Okay, let's look at the first type of boundary, plate boundary. We are talking of divergent boundaries. Divergent माने क्या? दूर जाने वाले, right? So we are talking of divergent boundaries माने plates are being pulled away from each other. Okay, they are also called as constructive boundaries. People, you have to remember this. Divergent का D and constructive का C. Okay, just remember this combination. So we are saying divergent boundaries are constructive boundaries. Constructive boundaries क्यों? Let's say if the plates are being pulled in opposite directions. Okay, we are saying that the plates are now being pulled in opposite directions. Clearly, the lava is going to be the upwelling of the lava is going to happen here, which means new crust is being created over there, which means that these are constructive boundaries. Okay, divergent boundaries are always constructive boundaries. Okay, the region where these plates move away, they are called as spreading sites. Okay, because lava spread होता है ना, वहाँ पे lava spread होगा, फिर उसका नया crust बनेगा, so on and so forth. So those are spreading sites. Okay, and these are the features usually which are associated with it. Ridges and rifts. Okay, if the plates are being pulled in two opposite directions, if this is one direction, this is another direction, clearly there's going to be a gap over here, right? इतना बड़ा नहीं, लेकिन छोटा मोटा तो गैप होगा वहां पे. तो वो जो गैप होता है वहां पे रिफ्ट बनते हैं. Have you ever heard of the East African Rift Valley? हाँ, rift system, right? So such rifts happen over there. नर्मदा का rift है ना? नर्मदा throws through a rift valley, right? तो उसका जो rift है. So we are saying such rifts happen over here. Ridges वगैरह जो बनते हैं, ये जो ridge बनता है जहां से फिर वो plates को दूर कर देते हैं and नया upwelling होता है lava का, तो ridges and all happen over here. These places are extremely famous for volcanic activity, clearly because the lava is coming out. Okay, the magma is coming out of there, and you can see volcanic activity over there. A very famous example is Mid-Atlantic Ridge. Okay, give me one moment until I show you. Can you see this picture? No, you can't yet. Now you can see this picture, right? Huh? This is the Mid-Atlantic Ridge. When I'm talking about the Mid-Atlantic Ridge, I am talking about this Atlantic Ocean. Okay, we are talking about this Atlantic Ocean. We are saying इसके बराबर बीच में से there is a mountain chain. Okay, a submerged mountain chain, a longest mountain chain on this earth runs through the Atlantic. Okay, right in the middle of the Atlantic, there is a submerged mountain chain. It is made up of volcanic mountains, clearly because the lava keeps upwelling over there. ये जो दोनों plates है, ये दोनों side पे चले जाते हैं, and बीच में वो lava का upwelling हो रहा है, and clearly वहाँ पे नया crust बनते जा रहा है, and उसका एक अच्छा खासा नीचे mountain range बन गया. Okay, समुद्र के नीचे. All good here? Everyone with me so far? Okay, so this mountain ridge is being formed. It is called as the Mid-Atlantic Ridge. Okay, अब ये Mid-Atlantic Ridge जब तक Atlantic Ocean में से चलती है तब तक ठीक है, हम उसको देख नहीं पाते, लेकिन Mid-Atlantic Ridge यहाँ से भी एक्सटेंड करती है आइसलैंड के ऊपर से. ओके, ऊपर आइसलैंड दिख रहा है आपको, तो वहां से भी एक्सटेंड करती जाती है, एंड जब वो आइसलैंड पे दिखती है तो कुछ ऐसी नजर आती है. This is how it looks like. Can you see? This is the formation. This is the granitic basaltic formation that you can see. In this case, it will be a तो and उसके बीच में से फिर and ये clearly gap नजर आ रही है आपको जहां से वो अब तक नहीं दिख रहा. ओके, अभी नजर आ रहा है. वी आर सेइंग ये जो दोनों है वो रिच के दो पार्ट्स है, राइट, एंड बीच में वो रिफ्ट बनी है, एंड क्लियरली यू कैन सी द स्टोन फॉर्मेशंस. वो जो लावा जो आराम से कूल डाउन कंसोलिडेट सॉलिडिफाई हो गया है वो नजर आ रहा है अभी आपको साइडवेज, एंड बीच में वो रिफ्ट है अभी भी. तो लैंड के ऊपर ये कुछ ऐसा दिखाई देता है. ओके, द मिड अटलांटिक रिज लुक्स समवॉट लाइक दिस. सी, दिस इज अ फार बेटर पिक्चर. नाउ यू कैन मेक आउट इवन बेटर. अब तो ये लैंड पे ही दिखाई देगा कि रिच के दोनों तरफ आपको दो चीजें नजर आएंगी, और बीच में this takes a little time. हाँ, नजर आ रहा है आपको? कैन यू सी द टूरिस्ट ओवर देयर? कैन यू सी एन एंटायर लाइन ऑफ टूरिस्ट ओवर देयर? रास्ता उन्होंने बनाया है, रास्ता आइसलैंड ने बनाया है, लेकिन ये जो रिज है वो क्लियरली ओरिजिनली नेचुरली बना है. ओके, सो दिस इज द मिड अटलांटिक रिज दैट वी आर टॉकिंग अबाउट. ऑलराइट, नेक्स्ट यू कम टू कन्वर्जेंट बाउंड्रीज. कन्वर्जेंट माने क्या? ज्वाइनिंग टुगेदर. ओके, तो कन्वर्जेंट बाउंड्रीज जो होते हैं उसमें प्लेट्स कन्वर्ज बिकॉज द currents are pushing them together. Okay, and these boundaries are called as destructive plate boundaries. See, कन्वर्जेंट सी के साथ डी डिस्ट्रक्टिव जाता है. रिमेंबर दिस कॉम्बिनेशन. ओके, सी के साथ डी, डी के साथ सी. रिमेंबर दोस. ऑलराइट. तो कन्वर्जेंट बाउंड्रीज के साथ हमेशा डिस्ट्रक्ट, कन्वर्जेंट बाउंड्रीज आर ऑलवेज कॉल्ड एज डिस्ट्रक्टिव प्लेट बाउंड्रीज, बिकॉज व्हाट हैपेंस इन कन्वर्जेंट बाउंड्रीज इज ये जो दोनों प्लेट्स होते हैं, दे कम टुगेदर. ओके, एट सम पॉइंट ऑफ टाइम अगर वो प्लेट्स रिजिड नहीं होंगे तो फोल्ड वोल्ड हो जाएंगे, कुछ कुछ हो जाता है उसके साथ. ओके, एंड देन एट सम पॉइंट ऑफ टाइम जो ओल्डर डेंसर प्लेट होता है वो जो नए प्लेट होता है उसके नीचे चला जाता है, and this process is called as subduction. You see what is happening? It goes below the old newer plate and that process is called as subduction. ये जो नीचे वाला पार्ट है उसको subduction zone कहते हैं, and that is a very very vulnerable seismic zone. Okay, वहां पर seismic activity बहुत जोर शोर से होती है. seismic meaning earthquakes वगैरह जो होते हैं ना वो बहुत वहां पर हो जाते हैं. Okay, so ये जो destructive plate boundaries होते हैं उसमें क्या हो जाता है, we are saying कि one plate, these are two plates, okay, they are coming together, so one plate goes beneath the other plate. Okay, अब ये जो पोर्शन प्लेट का नीचे चला गया वो क्लियरली एस्टेनोस्फीयर में मेल्ट हो जाएगा बिकॉज इट गोज इनटू द एस्टेनोस्फीयर, तो इट इज बीइंग डिस्ट्रॉयड. राइट, दिस पोर्शन ऑफ द प्लेट इज बीइंग डिस्ट्रॉयड, सो दिस इज कॉल्ड एज अ डिस्ट्रक्टिव बाउंड्री. ओके, सो जब कन्वर्जेंट बाउंड्रीज होते हैं तो क्लियरली पार्ट ऑफ द प्लेट इज बीइंग डिस्ट्रॉयड एंड हेंस दीस आर कॉल्ड एज डिस्ट्रक्टिव प्लेट बाउंड्रीज. ओके, जिस रीजन में ये सिंक हो रहा है, ये जो पोर्शन है, दिस पोर्शन that is called as a subduction zone, क्योंकि ये plate subduct हो रहा है, right, it is going beneath the other plate, it is being subducted beneath the other plate, so that is called as a subduction zone. All right, and ये जो subduction zone होता है इसका एक और नाम है, I'll give it to you. Wadati, Japanese guy, Benioff. It is called as the Wadati-Benioff zone. Okay, famously called, the subduction zone is famously called as the Wadati-Benioff zone, named after two people who worked extensively on this particular matter. Okay, and this zone is extremely seismically sensitive. बहुत ज़्यादा scary sensitive होता है. अक्सर subduction zones के साथ हमेशा earthquakes. Oh, okay. We'll start again ना कल की तरह. Oh, ये बीच में से क्या होता था उसको? मैंने कुछ किया? अच्छा नहीं. तो ये जो वादाती बेनियोफ जोन है, दैट इज कंसिडर्ड एज द, ये जो सबडक्शन जोन होता है दैट इज कंसिडर्ड एज एन एक्सट्रीमली साइस्मिकली सेंसिटिव प्लेस. ओके, तो वो हो जाता है. इनके साथ यूजुअली ट्रेंचेस एसोसिएट होते हैं या फोल्ड माउंटेन्स एसोसिएट हो जाते हैं. प्लीज रिमेंबर, इफ दीस प्लेट्स आर बीइंग, इफ द लैंड इज अ लिटिल जो क्रस्ट जो होता है जो कन्वर्ज कर रहा है, इफ दैट इज अ लिटिल सॉफ्ट, ओके, नॉट एक्सट्रीमली हार्ड रॉक, थोड़ा सॉफ्ट रॉक होगा तो उसका फोल्डिंग हो जाता है कुछ इस तरह से. सी, इफ आई एम गोइंग टू स्टार्ट pushing this paper in two directions. Okay, if I want to start pushing this paper in two directions, in a while the paper is going to get folded, right? If I start pushing this paper, now it is not being folded in the right direction. If I start pushing this paper, it will start getting folded, right? Why? Because it is soft, right? It is soft. If I start pushing this phone in two directions, it will break. Why? Because it is hard. Okay, so depending on the type of crust we have, depending on the type of crust that is available, and the nature of the crust, the folding, either when there is a convergent boundary, either folding will happen or then the crust will break. Okay, either of these conditions will happen, right? So we are saying that this is very closely associated with trenches and fold mountains. Fold mountains अगर rock soft होंगे तो clearly fold mountains बन सकते हैं, क्योंकि clearly push कर रहे हैं दोनों एक direction में, तो ऐसे fold हो जाता है crust. Okay, so वो आपके fold mountains बन जाते हैं. Trenches माने, see, ये जो प्लेट एक दूसरे के नीचे जा रहा था ना, तो ये वाला सेक्शन बनता है ना, दैट इज कॉल्ड एज ए ट्रेंच. ओके, ये ओशियानिक ट्रेंचेस जो होते हैं ना, दे आर द स्कैरियस्ट प्लेसेस इन द वर्ल्ड. ओके, मतलब स्पेशली इफ यू आर इनटू डीप सी डाइविंग एंड ऑल, दीस प्लेसेस आर कंसिडर्ड वेरी वेरी स्कैरी. ओके, मरियाना ट्रेंच फॉर एग्जांपल, यस, the deepest trench, deepest place in the earth, right? So we are saying these trenches, fold mountains, seismic zone, ये सब कुछ इससे related है, convergent plate boundaries से related होता है. Himalayas being a very major example of it. Fold mountains है, Himalayas के साथ साथ बाकी alpine और इसके माउंटेन्स मिल जाते हैं आपको अल्पाइन रेंज के. यू विल फाइंड द एल्प्स in Europe, you will find Rockies in North America and Andes in South America. Andes is the longest mountain chain on the surface of the earth. Mid-Atlantic range is the longest mountain chain below the in generally on earth, but below the water. Okay, okay, ठीक है. अब मैं ट्रांसफॉर्म बाउंड्री सिखा देती हूँ आपको. And then we can take a break. Okay, ठीक है. Transform boundaries माने, they are called as conservative boundaries. Because hey, our guys back there, I don't, once again, I'm repeating myself. I don't mind if you're not paying attention, but you cannot talk. Either that or you look for another place to sit and talk, whatever you're doing. And be mindful your attendance gets recorded with भैया. अगर भैया ने कल को आपको पूछा कि what you guys learned in this class, I'm afraid you will not be even be able to tell the name of the topic. Endogenic processes, tectonic plates. So अगर ऐसा कुछ बोल नहीं पाएंगे आप लोग अगर आप ध्यान नहीं देंगे तो. Scary people, man. Anyways, transform boundaries is the plates are neither coming together nor are they moving away. What is happening is they're sliding right past each other. Okay, इस तरह से slide करते रहते हैं वो. So these are called as transform boundaries. तो यहाँ पे ना तो crush create होता है ना destroy होता है. So hence that is called as conservative boundaries या shear. Shear माने ऐसा breaking वाला जो action होता है वो. तो shear plate boundaries बुलाते हैं उसको. Okay. ये जो ट्रांसफॉर्म फॉल्स होते हैं ना, दे यूजुअली फाउंड ऑन द ओशन फ्लोर. ये थोड़े रेयर होते हैं. ट्रांसफॉर्म बाउंड्रीज आर अ बिट रेयर बाउंड्रीज. ये यूजुअली आपको मिड ओशियानिक रिज पे मिल जाते हैं. सी दिस इज द मिड ओशियानिक रिज. ओके, ये जो नजर आ रही है आपको, ये अटलांटिक ओशन के बीच में मिड ओशियानिक रिज है. इसके ऊपर वो ऐसे क्रिस क्रॉस कट्स दिखाई दे रहे हैं. दोस आर ऑल द ट्रांसफॉर्म बाउंड्रीज. ओके, वो सारे ट्रांसफॉर्म बाउंड्रीज है. ये तीनों बीन मोर फेमस. सेंट पॉल्स, रोमांस, चेन, ये तीन मेजर फॉल्ट्स है यहाँ पे, ट्रांसफॉर्म फॉल्ट्स है. तो ये तीन आपको यहाँ पे, मतलब दिस इज वेयर यू फाउंड मोस्ट ऑफ द ट्रांसफॉर्म फॉल्ट्स. ओके, ये आपको यहाँ पर मिल जाते हैं मिड अटलांटिक में. सैन एंड्रियस एक है, वो दिखा देती हूँ मैं आपको. ये कैलिफोर्निया में बहुत लंबा चौड़ा, कुछ 250 किलोमीटर वगैरह वाला लंबा सा एक फॉल्ट है. ओके, इट इज अ स्ट्राइक स्लिप फॉल्ट, मीनिंग ट्रांसफॉर्म बाउंड्री है वो. द प्लेट्स आर मूविंग लाइक दिस. ऐसे प्लेट्स मूव कर रहे हैं एंड ये आपको क्लियरली दिखाई देता है. इफ यू स्टैंड एट दिस ना, तो आपको क्लियरली नीचे तक बहुत गड्ढा गड्ढा सा नजर आता है. ऐसे इतना तो विड्थ होता है, आराम से विड्थ मिलता है आपको. क्लियरली देयर इज अ प्रॉपर chasm there. एंड यू कैन सी दिस. ऐसे नॉर्मली दिखाई देता है आपको. यू कैन इवन नाउ यू कैन मेक आउट कि वो कितना लंबा दूर तक जा रहा है, राइट? एंड वो कितनी दूर से आ रहा है. तो क्लियरली दिस इज अ प्रॉपर फॉल्ट एंड दिस इज अ प्रॉपर साइस्मिक जोन फॉर कैलिफोर्निया. कैलिफोर्निया के सारे अर्थक्वेक्स एंड प्रॉपर वोल्केनिक एक्टिविटीज जो है वो इसके साथ क्रिएट की जाती है, सैन एंड्रियस फॉल्ट के साथ. ओके, सो दिस इज सैन एंड्रियस फॉल्ट इन साउथ इन कैलिफोर्निया. एंड ये मोस्ट ऑफ द फॉल्ट रन्स थ्रू द लैंड एंड देन सम ऑफ इट आल्सो गोस थ्रू द ओशियनिक क्रस्ट. ओके, so that is how this works. So this is San Andreas fault for you, famous transform boundary. Take a break. Meet again in 5 minutes. Yeah. Getting what we said, little, not the whole thing. We are on. So far, we have seen the different types of plate boundaries, divergent, conversion, and transform. And now we are moving forward. And the last example that we saw for transform boundaries was San Andreas Fault. Okay. Now we go on to little trivia. Which of the plates are larger? So size-wise, Pacific plate has to be the largest plate, and Juan de Fuca has to be the smallest plate. Okay, and it is going to be even smaller because it is being subducted under the North American plate. In a while, in a few thousand million years, it is going to just pass out of public knowledge. Okay. Now, rate of movement is the fastest plate. Each plate will also have a different movement depending on what kind of forces are being pulling it or pushing it in whatever direction. So the fastest plate is the East Pacific Rise, the Cocos and Nazca plates together near the Easter Islands. And the slowest plate is going to be the Arctic Ridge. Okay, Arctic Ridge is supposed to be the slowest plate ever. It travels at the rate of some 2.5 centimeters per year. Usually इसके ऊपर questions नहीं आते हैं, but then once again I'm not discounting UPSC कि वो कोई question पूछ लेंगे या नहीं पूछेंगे या whatever. Okay. Okay. This is a very important topic, the movement of the Indian plate. Okay, like we discussed earlier, from the evidence that you saw in the continental drift theory, you know that many of the southern hemisphere, land masses in the southern hemisphere and India have the same kind of fossils. Okay, they all share the same sort of fossils, which means there is clear evidence that India once belonged to the southern hemisphere, and from there it has migrated all the way to the northern hemisphere. Okay, so we are watching that movement. We are going to track that particular movement. Okay, and what happened to the Indian plate while it was making that movement. So it moved from the southern hemisphere to the northern hemisphere. See, this is where the plate was originally. Okay, this is where the plate was over here, and then dhire it moved right up to there. Okay, so we are saying around 71 million years ago, the plate was somewhere over here, and then it moved to this particular part where it is today. All right. Now, while it was making that movement, some 66 million years ago, it passed by this point. I'll show you which point. This point. Okay. The plate was somewhere over here, right? So while it was passing in this particular direction, it passed by this particular point. यहाँ पर ना एक Reunion Islands नाम की जगह है. Okay. Reunion hotspot is a very famous volcanic hotspot. Okay. So what happened over there was that while the Indian plate was moving in that particular direction, वो वहां पे लावा का आउटपोरिंग हो रहा था मल्टीपल सीक्वेंशियल प्रोसेस में, मल्टीपल एपिसोड्स में हो रहा था. तो क्लियरली वो सारा लावा का आउटपोरिंग इंडियन प्लेट को भी मिल गया, जिसका ये हमको क्या मिला, हमको उसका क्या पैदा हो गया, हमको यहाँ का जो डेक्कन प्लेटो है वो वहां से मिला है. ओके, 66 million years ago, thanks to the gift from Reunion Islands, Reunion hotspot, we got this particular Deccan plateau over there. Okay, which is a proper Cretaceous period का plateau है हमारा. अच्छा खासा plateau बना के गया है. Multiple episodes का you can see multiple layers, multiple episodes हो गए हैं, and multiple outpourings of lava have finally built that plateau to this particular point. Okay, because कहीं भी इंडिया में आपको कहीं मेनलैंड पे कोई वोल्केनिक एक्टिविटी नजर आती है क्या? नहीं, there is no volcanic activity, right? We have one volcano over here in Andaman and Nicobar Islands, Barren Island, right? We have that one volcano, but it is outside India. वो इंडिया के बाहर लाई करता है, वो मेनलैंड इंडिया पे लाई नहीं करता है. We had no reason to have a Deccan plateau over here. We had no reason to have a proper volcanic plateau here. Okay, this comes from that volcanic Reunion Islands for hotspot. All right, that is what we were looking at. And then the next thing that happened was the Indian plate was still moving in the upward direction, northward direction में move कर रहा था. Some 60 million years ago, it was still somewhere near the equator, and then it crossed the equator and started moving towards the Eurasian plate. Okay, अब वो यूरेशियन प्लेट के साथ उसका सबडक्शन हो रहा है. वो इंडियन प्लेट इज बीइंग सबडक्टेड अंडर द यूरेशियन प्लेट, एंड वहां पे क्रस्ट सॉफ्ट होने की वजह से फोल्डिंग हो गया है. बहुत मैसिव, बहुत मेजर, वेरी कॉम्प्लेक्स एंड कॉम्प्लिकेटेड फोल्डिंग हो गया है, जिसकी वजह से इतने सुपर्ब स्पेक्टेक्युलर हिमालयाज मिल गए. ओके, सो दैट हैपेंड समटाइम इन द where do we say formation of Himalayas is some 50 million years ago. Okay, we say the Himalayas were formed some 50 million years ago, and that is where you see that. तो ये दो गिफ्ट्स हमको ये प्रोसेस में मिल गए हैं, एक वो डेक्कन प्लेटो और दूसरा वो हिमालयास. ओके, बिकॉज द लैंड वाज बीइंग वहां पे सबडक्शन हो रहा था एंड लैंड फोल्ड हो गया था, इसके लिए हमको हिमालयास मिल गया. अभी गुड हियर, समझा आपको ये? Let's get a very brief introduction on what geomorphic processes are. We have 50 minutes. Okay. Geomorphic processes, geo meaning earth, morph means change. Okay, तो geomorphic processes माने कि वो processes जिसकी वजह से earth का surface change हो जाता है. Okay, the surface of the earth changes, ऐसे process को geomorphic बुलाएंगे. उसके हम दो divisions करते हैं broadly. We call that as endogenic forces and exogenic forces. Endogenic माने अर्थ के अंदर से, विद इन इंटरनली अर्थ के अंदर से जो फोर्सेस एक्ट करते हैं जिसकी वजह से अर्थ का सरफेस चेंज होगा, those will be called as endogenic processes. Okay, whereas exogenic processes माने वो जो फोर्सेस है जिसकी वजह से अर्थ का सरफेस चेंज हो रहा है, they are external to the earth, like बाहर का विंड, बाहर का रेन, बाहर का रनिंग वाटर, these are external to the earth, right? उनका अर्थ के इंटरनल मैकेनिज्म से कोई मतलब नहीं है. So we are saying those are exogenic forces. Okay, now endogenic forces पे concentrate करते हैं, because in this particular chapter we are only going to look at endogenic forces. Okay, तो एंडोजेनिक मूवमेंट्स जो है उसको हम वापस दोबारा क्लासिफाई कर लेते हैं, स्लो मूवमेंट्स एंड सडन मूवमेंट्स. ओके, सडन मूवमेंट्स आर वेरी क्लियर, वोल्केनोस एंड earthquakes. Okay, वो ऐसे झट से हो जाते हैं, आपके सामने हो जाते हैं, दुनिया बदल जाती है 2 मिनट के अंदर. लाइक earthquakes में तो इट इज वोल्केनिज्म तो भी कम से कम एपिसोड्स में हो सकता है कि यार आज थोड़ा सा इरप्ट हो गया, कल थोड़ा सा इरप्ट हो गया, महीना भर इरप्ट हो रहा है, so on and so forth. Okay, earthquakes can be very quick, very fast. There is no idea, you have no clue that they are coming, you have no clue what to do while the earthquake is happening. It happens within a few seconds. It can be very severe, it can be moderate, it breaks down the infrastructure and everything is done. Okay, and then there are later you can feel a few tremors later on. Okay, so that's what these are, sudden movements where you do not have any idea how that is happening. You cannot see that, you can see while the event is happening, but you have no clue why, when it is going to happen. Okay, those are sudden movements, volcanism and earthquakes. Now look at the slow movements. Slow movements में आपको दो movements मिलती है, वर्टिकल ऐसे वाले मूवमेंट्स मिलेंगे या फिर हॉरिजॉन्टल. वो जो प्लेट के मूवमेंट्स देखे वो हॉरिजॉन्टल मूवमेंट्स है. ओके, तो ये वाले जो मूवमेंट्स होते हैं हॉरिजॉन्टल मूवमेंट्स, दे विल हेल्प इन माउंटेन बिल्डिंग. ओरिजेनिक मूवमेंट्स बुलाते हैं उसको, वो माउंटेन बिल्डिंग में हेल्प करते हैं. ओके, अब उसमें दो केसेस हो सकते हैं. लाइक आई सेड, अगर वो कंप्रेस हो रहा है लैंड तो फोल्डिंग हो सकता है एंड आपको प्रॉपर फोल्ड माउंटेन्स मिल सकते हैं, या फिर अगर वो लैंड, अब ये तो दोनों केसेस में होगा, या तो लैंड कंप्रेस होगा या फिर टेंशन, इट्स बीइंग पुल्ड अपार्ट इन ऑपोजिट डायरेक्शंस, तो ब्रेक हो जाएगा लैंड. अगर हार्ड क्रस्ट भी होगा तो भी फोल्डिंग में भी ब्रेक ही हो जाएगा, वो कंप्रेशन में भी ब्रेक हो जाएगा. एंड वंस दैट हैपेंस तो फिर फॉल्ट्स डेवलप होते हैं, तो ब्लॉक माउंटेन्स वगैरह बन जाएंगे. ओके, ठीक है. सो दीज फोर्सेस ऑफ टेंशन और कंप्रेशन कैन बोथ अमाउंट टू ब्लॉक माउंटेन्स, whereas forces of compression can, fold mountains can only be formed if the compressional forces are acting. Okay, this is the horizontal movement. Okay, vertical movements या तो upward होंगे या तो downward होंगे. Okay, upward माने uplift होता है, पूरा का पूरा continent ऐसे पानी में से उभर कर ऊपर आ जाता है. Okay, पानी में से मतलब reference के लिए पानी water level ले रही हूँ मैं, sea level ले रही हूँ, but we are saying that entire continent is being uplifted. Okay, तो उसको एक uplift माने upward movement बुलाते हैं. And then there is a downward movement or a submergence where entire continent is being पुल्ड डाउनवर्ड्स, ओके, वो थोड़ा सा नीचे की तरह सबमर्ज कर जाता है एंड विद लेवल विद वाटर, मतलब सी लेवल के कंपैरिजन में देखो तो, ओके। ये जो मूवमेंट्स होते हैं दे आर फेमसली कॉल्ड एज वर्टिकल मूवमेंट्स और एपायरोजेनिक मूवमेंट्स। कॉन्टिनेंट बिल्डिंग मूवमेंट्स जो होते हैं उनको एपायरोजेनिक मूवमेंट्स कहते हैं एंड हॉरिजॉन्टल या माउंटेन बिल्डिंग मूवमेंट्स जो होते हैं उनको ओरोजेनिक कहते हैं। ओरो इज द एडजेक्टिव फॉर माउंटेन्स, एपायरो इज द एडजेक्टिव फॉर कॉन्टिनेंट्स। क्लियर सो फार? इस चैप्टर में वी आर गोइंग टू स्पेसिफिकली लुक एट एंडोजेनिक मूवमेंट्स, राइट। एक्सोजेनिक मूवमेंट्स का एक बहुत ब्रीफ ये देती हूँ मैं आपको आइडिया। एक्सोजेनिक मूवमेंट्स माने एक्सटर्नल फैक्टर्स की वजह से अर्थ का सरफेस चेंज होता है, इरोजन होगा, वेदरिंग होगा, डिपोजिशन होगा, तो उसकी वजह से अर्थ का सरफेस चेंज होता है, द जियोमॉर्फोलॉजी लुक्स डिफरेंट, ओके। वेदरिंग कैन बी फिजिकल, केमिकल, बायोलॉजिकल, है ना, दैट वी हैव स्टडीड सो फार। इरोजन कैन बी बिकॉज ऑफ दीस 5 एजेंट्स, रनिंग वाटर, ग्राउंड वाटर, कोस्टल सी वेव्स वगैरह, वो सब कुछ, वेव्स एंड करंट्स, ग्लेशियर्स या फिर winds, है ना, these can all cause in very specific places, these can cause erosion also and they can cause deposition also, है ना। these are famous agents जिनकी वजह से erosion भी होता है, deposition भी होता है। these two together, weathering and erosion together, is called as denudation। याद रहेगा, ओके, क्योंकि ये एक एक करके अर्थ का लेयर स्ट्रिप कर डालते हैं, दे आर लिटरली स्ट्रिपिंग अवे लेयर बाय लेयर फ्रॉम द अर्थ। बोथ दीज मूवमेंट्स, whether it is weathering, whether it is erosion, it is stripping away the layers of the earth and hence that is called as denudation। deposition is adding to the layers of the earth, okay, वो जाके डिपॉजिट कर रहा है चीजें जिसकी वजह से अर्थ के जो लेयर्स होते हैं उसका उसका रिलीफ बढ़ रहा है, ओके, अर्थ का रिलीफ बढ़ता है विद डिपोजिशन। विद वेदरिंग एंड इरोजन अर्थ का रिलीफ जो होता है वो लोअर हो जाता है, ओके। रिलीफ समझता है आपको, दिस इज द रिलीफ ऑफ द अर्थ। वो जो आपको ऊपर ऊपर ऐसे चीजें नजर आती है अर्थ के सरफेस के ऊपर, जो भी स्टैंडिंग चीजें नजर आती है, दैट विल बी द रिलीफ ऑफ द अर्थ। तो अर्थ का रिलीफ लोअर करता है बोथ वेदरिंग एंड इरोजन, व्हेरेज अर्थ का रिलीफ ऑल्टीट्यूड में हाई बनाता है डेपोजिशन का प्रोसेस, ओके। क्लियर सो फार? Here we are, okay, we are looking at all the endogenic processes। तो slow movements है epirogenic and orogenic processes, and दो sudden movements होंगे volcanism and earthquakes, alright, ठीक है। Now let's look at what endogenic processes are। Endo meaning internal, अंदर से जो आएगा वो अर्थ के अंदर से। जेनिक माने जेनेसिस, मीनिंग उसका ओरिजिन पॉइंट वो होगा, ओके। एंडोजेनिक फोर्सेस माने ऑल दोस प्रोसेसेस जो अर्थ के इंटरनल एनर्जी पे बिल्ड करते हैं, अर्थ की इंटरनल एनर्जी से शुरू होते हैं, ओके। तो ये लार्ज स्केल मूवमेंट्स होती है, these are अभी क्लियरली माउंटेन बिल्डिंग, कॉन्टिनेंट बिल्डिंग और लार्ज स्केल मूवमेंट्स। इट्स नॉट यू टॉकिंग ऑफ दिस लिटिल पीस ऑफ लैंड, यू आर टॉकिंग ऑफ अ ह्यूज एक्सपांस ऑफ लैंड, ओके। सो लार्ज स्केल मूवमेंट्स होती है ऑन द अर्थ्स क्रस्ट and these are brought by forces। how are these brought about? By the forces which are emanating from the earth's crust। अब ये जो हमने देखा वो एस्ट्रोनोस्फीयर में कन्वेक्शनल करंट सेटअप हो रहे हैं, these are movements within the earth surface, right, within the earth's body। तो ये ऐसे वाले forces जो अर्थ के अंदर से डीप बिलो फ्रॉम द अर्थ सर्फेस आते हैं एंड दे विल चेंज द सर्फेस ऑफ द अर्थ, तो उनको बुलाएंगे एंडोजेनिक जियोमॉर्फिक मूवमेंट्स, ओके। सेम प्रोसेस, फोल्डिंग फॉल्टिंग वगैरह होता है। पॉजिटिव फोर्सेस वंस अगेन द सेम जो कन्वेक्शनल करंट्स के लिए है। ओरिजिनली अर्थ के कोर में पहले से ही वो प्राइमोर्डियल हीट बची थी, जब से वो बनी थी अर्थ तब से वो प्राइमोर्डियल हीट बची थी। ऊपर से उसमें जाके सारा डेंस मटेरियल गिर गया है, सारा रेडियो एक्टिव डीके होता है, वो बहुत अमाउंट ऑफ एनर्जी रिलीज करता है एंड उसकी वजह से ये जो कोर वाला पार्ट है मैंटल का, वो बहुत नीचे वाला पार्ट वो बहुत हॉट है, वो जो ऊपर वाला पार्ट है मैंटल का वो उतना हॉट नहीं है। बिकॉज ऑफ द टेम्परेचर डिफरेंसेस कन्वेक्शनल करंट्स आर बीइंग सेट अप, they are either pulling the plates away or they are pushing the plates together or they are simply letting the plates slide by, okay। this is what is happening, this is the positive force of all endogenic processes। are we good? एपायरोजेनिक मूवमेंट्स, आपको एपायरोजेनिक मूवमेंट्स पे ना ज्यादा क्वेश्चंस नहीं आते हैं, यूजुअली ओरोजेनिक पे आते हैं, लेकिन एपायरोजेनिक मूवमेंट्स पे ए यार बॉयज, अच्छा आप तो सिर्फ फोन में है, नो वरीज। नहीं, मैं आपके पीछे जो दोनों हैं उनको बता रही थी, एक्चुअली उनका बड़ा आवाज है, वो तो खिलखिला के हंस भी रहे, तो as long as you don't disturb me, I really don't care what you do। एनीवेज, तो एपायरोजेनिक मूवमेंट्स जो होती है उनको यूजुअली ओरोजेनिक के साथ कॉन्ट्रास्ट करके क्वेश्चंस पूछे जाते हैं कि यू कॉन्ट्रास्ट एपायरोजेनिक मूवमेंट्स विद ओरोजेनिक मूवमेंट्स। यू से कि ओरोजेनिक मूवमेंट्स जो होती है वो छोटे से एरिया को अफेक्ट करते हैं, एपायरोजेनिक बड़े बड़े कॉन्टिनेंट्स को अफेक्ट करते हैं। एपायरोजेनिक में हल्के हल्के अंडुलेशंस होंगे, ओरोजेनिक में बहुत कॉम्प्लिकेटेड डिफॉर्मेशन हो जाएगा लैंड का। तो इस तरह से कंपेयर एंड कॉन्ट्रास्ट करके आप यूजुअली एपायरोजेनिक को स्टडी करेंगे, ओके। एपायरोजेनिक मूवमेंट्स जो होती है दे आर वर्टिकल मूवमेंट्स मीन्स माने लैंड इज लिटरली बीइंग अपलिफ्टेड और द लैंड इज बीइंग सबमर्ज्ड, ओके, आइदर ऊपर की तरफ मूव कर रहा है लैंड या नीचे की तरफ मूव कर रहा है, साइडवेज फंक्शन, साइडवेज मूवमेंट नहीं है आपके पास यहाँ पे, ओके, दीज आर आल्सो कॉल्ड एज रेडियल मूवमेंट्स। ट्राई टू लुक, से सपोज ये अर्थ है, हाँ, और ये वो हिस्सा है, दिस इज दैट पार्ट ऑफ द, this is that lithospheric plate which is either moving upwards or downwards, okay, एपाइरोजेनिक होने के लिए ये वाला पार्ट है, ओके। अब अगर मैं कहूँ कि इट इज सबमर्जिंग, वो नीचे की तरफ जा रहा है, तो वो किस डायरेक्शन में, ये बारिश हो रही है क्या? Okay, no worries, 50 minutes later. So let's say कि now this is being submerged, okay, let's say ये submerge हो रहा है, तो ये किस डायरेक्शन में जा रहा है? ये इस डायरेक्शन में नीचे की तरफ जा रहा है, right? The plate is going in the direction downwards. Which direction is it acting along? Along the radius, right? तो ये रेडियल मूवमेंट्स होती है, okay? अगर ये ऊपर की तरफ जाने की कोशिश कर रहा होगा तो किस डायरेक्शन में जाएगा? इस डायरेक्शन में जाएगा, अपवर्ड्स डायरेक्शन में जाएगा, once again acting along the radius. तो इन मूवमेंट्स को या तो वर्टिकल कहते हैं या रेडियल मूवमेंट्स कहते हैं, प्लीज रिमेंबर दीस टू, वर्टिकल और रेडियल मूवमेंट्स कहते हैं उसको, बिकॉज दे एक्ट along the radius of the earth. Now either they are acting towards the center, अगर submerge हो रहा है तो the movement, the force is acting towards the center, and if they are, if it's an uplift then it's acting away from the center, okay, clearly away from the center if it's an uplift, towards the center if it is a submergence, all right, ठीक है। ये movements अक्सर orogenic movement से slower होती है, when I'm saying slower there is a different time scale, okay, इनको बनने के लिए कुछ 150, 200, 300 मिलियन साल लग जाते हैं, ओके, एपाइरोजेनी को एक्चुअली दिखने के लिए, प्रॉपर्ली दिखने के लिए 150, 200, 300 मिलियन साल लग जाते हैं, whereas orogenic movements 50, 60 years, 100 million years में काम हो जाता है, okay, this is done, the whole process is done। अब हिमालयस पिछले 50 मिलियन साल से बन रहे हैं, okay, अभी भी चल रहा है उसका प्रोसेस, say another few 10, 20 million years चलेगा, फिर रुक जाएगा, थम जाएगा, right, that is what is going to happen, we are expecting that is what will happen, okay, so we are saying कि ये जो एपाइरोजेनिक मूवमेंट्स होते हैं उनका जो पीरियड होता है वो भी बहुत बड़ा होता है, ओके, 150 to 100 मिलियन इयर्स, and they affect extensive parts of the earth's crust, बहुत बड़े बड़े एरियाज को, पूरा का पूरा साइबेरियन प्लेटो, पूरा का पूरा यू नो डेक्कन प्लेटो, वी आर सेइंग बहुत बड़े बड़े रीजन्स को अफेक्ट करते हैं, ओके, एंड दे कॉज अपहीवल्स और डिप्रेशंस ऑफ लैंड, एग्जिबिटिंग अंडुलेशंस। अब ये जो अपहीवल्स या डिप्रेशंस बनते हैं व्हाइल द लैंड इज बीइंग अपलिफ्टेड और व्हाइल इट इज बीइंग सबमर्ज्ड, वो जो पूरा का पूरा लैंड होता है ना, वो कुछ इस तरह से नजर आता है, यू नो, हल्के हल्के वेव्स के फॉर्म में दिखता है, अंडुलेशंस दिखते हैं, है ना, वैसा वाला नजर आता है, वो बहुत कॉम्प्लिकेटेड डिफॉर्मेशन नहीं होता है यहाँ पे, ओके, इन एपाइरोजेनी जो the land that is subjected to एपाइरोजेनी does not undergo a very complicated deformation, वो सिंपल सा डिफॉर्मेशन होता है, हल्का सा वेवी वेवी दिखने लगता है, ओके। यूजुअली एपाइरोजेनी happens to the most stable parts of the continents. See people, when I'm talking about continents or when I'm talking about plates, what I'm essentially saying is कि ये कोई irregular shape plate है, ये दूसरी कोई irregular shape plate है, ओके, तो you are saying कि इसके जो बाउंड्रीज है ये हमेशा vulnerable होंगे, क्यों? क्योंकि they will either be going and they can either be convergent or they can be divergent or they can be strike slip boundary, transform boundary हो सकता है, okay, तो boundary is always a problem, it's always a vulnerability। सबसे stable part कौन सा होता है कॉन्टिनेंट का? ये वाला, किसी भी प्लेट का जो सबसे सेंट्रल पार्ट होता है वो सबसे स्टेबल होता है, ओके, एपाइरोजेनी इस पार्ट को अफेक्ट करता है, इस पार्ट को कहते हैं क्रेटॉन, okay, that part of the plate or the continent which is most stable, which is away from all the boundaries, that is called as the craton, and that is the one that is affected by the epairogeny। तो epairogeny usually volcanoes या earthquakes जो होते हैं वो आपके बाउंड्रीज के अलोंग एक्ट करते हैं, प्लेट के जो बाउंड्रीज होते हैं ना वहां पर आपको उसका एविडेंस सबसे ज्यादा मिलता है, ओके, लेकिन क्रेटॉन्स जो होते हैं वो एपाइरोजेनी जो होता है वो क्रेटॉन्स को अफेक्ट करता है, ओके, सेंट्रल पार्ट को अफेक्ट करता है, एपाइरोजेनी यूजुअली अफेक्ट्स द सेंट्रल पार्ट ऑफ अ प्लेट और अ कॉन्टिनेंट। Are we good here? Please remember whatever questions UPSC ever poses to you about epairogenic or epairogenic only is always in contrast with orogenic। बहुत rarely वो आपको अकेले epairogeny पे question पूछते हैं, okay? It will always be a compare and contrast। epairogeny fast है या orogeny fast है, epairogeny ज्यादा एरिया को अफेक्ट करता है या orogeny करता है। It is always epairogeny which takes a long time and which affects a larger area and कम deformation देगा, okay? Clear? ये आपके एपाइरोजेनी के दो मूवमेंट्स, एक अपलिफ्ट और दूसरा सबमर्जेंस, ओके। ये वाला बीच वाला लाइन नजर आ रहा है आपको, बीच यहाँ तक था ओरिजिनली, ओके, दिस वाज द पॉइंट वेयर द बीच वाज, ओके, लैंड अपलिफ्ट हो गया है जिसकी वजह से अभी आपको ये वाला सेक्शन भी मिल गया है बीच का, ओके, इट्स अ रेज्ड बीच एंड यू कैन क्लियरली सी फ्रॉम द वेव फ्रंट प्लेटफॉर्म्स एंड ऑल कि वो रेस्ड बीच होता है। आपको कोंकण के यहाँ पे बहुत मिलता है ऐसे रेस्ड प्लेटफॉर्म्स वगैरह जो सेक्शन है वो कोंकण कोस्ट पे मिल जाता है आपको। ओके, सो वी आर सेइंग कि ये वाला जो सेक्शन है वो दिस इज कॉल्ड एज अ रेस्ड बीच। ये तभी मिल सकता है आपको जब वो पूरा का पूरा लैंड समुंदर में से बाहर निकलकर ऊपर की तरफ आ गया होगा। ओके, एंड दिस टेक्स अ लॉट ऑफ इयर्स टू शो, बहुत बहुत साल लगते हैं इसका एविडेंस दिखने में। ओके, तो क्लियरली ये सब है, दिस इज अ रेस्ड बीच। ओके, ये बीच में से ही उठ के समुद्र में के बीच में से एक आइलैंड उभर कर आ गया, दिख रहा है आपको यहाँ पे। हाँ, सो दैट आल्सो हैपेंस बिकॉज पार्ट ऑफ द कॉन्टिनेंट इज नाउ शोइंग अप। ओके, पार्ट ऑफ द कॉन्टिनेंट इज नाउ शोइंग अप हियर। लुक एट दीज टू, दिस इज एन आर्च। इसको ये जो साइड वाला पोर्शन है ना, इसको आर्च बुलाते हैं, सी आर्च बुलाते हैं। ओके, तो ये बेसिकली इरोजन का लैंडफॉर्म है, इरोजनल लैंडफॉर्म है। यूजुअली समुद्र के नीचे वगैरह होता है, लेकिन फिर ये अभी उभर कर ऊपर चला गया है। सी केव ऑल्सो समुद्र के नीचे था, अभी उभर कर ऊपर चला गया। ओके, तो ये सारा एविडेंस है अपलिफ्ट का कि वो लैंड ऊपर की तरफ अपलिफ्ट हो गया है। दीज आर ऑल एविडेंसेस ऑफ दैट अपलिफ्ट। ओके, सो वी आर सेइंग कि अपलिफ्ट में यूजुअली व्हाट इज हैपनिंग इज कि रेस्ड बीचेस नजर आते हैं, या फिर आपको एलिवेटेड वेव कट प्लेटफॉर्म्स नजर आते हैं, इस तरह से सी वेव्स या सी आर्चेस नजर आने लगते हैं। सो दीज आर ऑल एग्जांपल्स ऑफ सी लेवल, कि सी लेवल के ऊपर लैंड राइज कर गया है एंड तब जाके ये नजर आता है। हमारे यहाँ पे इंडिया में काठियावाड़, नेल्लोर एंड तिरुनेलवेली कोस्ट के अलॉन्ग हमको ये मिलता है। ओके, नेल्लोर इज आंध्रा के पास, तिरुनेलवेली इज तमिलनाडु के पास। सो वी आर सेइंग दीज आर द कोस्ट अलॉन्ग व्हिच यू विल फाइंड अपलिफ्ट। ओके, नाउ गो टू सबमर्जेंस, सबसिडेंस या सबमर्जेंस। वो बॉम्बे के पास आप लोगों ने कभी मड आइलैंड का नाम सुना है? देयर इज अ प्लेस ओवर देयर, मड आइलैंड। ओके, तो बॉम्बे का तो फंडा ही अलग है, इट वो उसका वो सबमर्जेंस का एंड सबसिडेंस का भी नेसेसरी ये नहीं है। बॉम्बे इज जस्ट एन आइलैंड व्हिच इज सर्वाइविंग बाय इटसेल्फ एंड थ्रू लक, प्लेनली लक पे सर्वाइव कर रहा है वो आइलैंड, बिकॉज इंफ्रास्ट्रक्चर तो हम कुछ कर नहीं रहे उसके लिए। द थिंग इज कि वो जो एरिया है ना, वो पानी का लेवल जब बढ़ता है तो उसका जो ग्राउंड है वो पानी के नीचे चला जाता है। ओके, दिस इज नॉट एग्जैक्टली एन एग्जांपल ऑफ सब्सिडेंस, मैं आपको सिर्फ एक्सप्लेन करने की कोशिश कर रही हूँ। तो अगर आप उसके जमीन के पास कोस्टल रीजन में अगर पास जाए ना, तो वहां पे एंटायर फॉरेस्ट, पेड़, पार्क्स, बेंचेस, गाड़ियां, बिल्डिंग ऐसे सब नजर आते हैं आपको। ऐसे डूबे हुए सबमर्ज्ड चीजें नजर आती है ऐसी आपको। लाइक यू कैन इजीली फाइंड अ स्मॉल बाइसिकल और अ scooter or a car or something just lying there in the water, submerged in the water. So this is an example of subsidence. When this happens on a large scale, when this happens on a geological scale, तो इसको subsidence बोलते हैं। यहाँ पर it is can simply be in the case of Bombay and Mud Island, it can be simply attributed to the fact that the water level has risen. Okay, water level पानी के जो land level है उसके ऊपर water level rise कर गया है, जिसकी वजह से ये नजर आ रहा है। But normally subsidence में what is happening is वो land नीचे 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 की तरफ जाते रहता है। द्वारका is a very good example, and the lost city of Dwarka is a very good example of submergence, where the entire city submerged. Let alone the mythological reason or whatever we have learned in the Mahabharata and the epics. Let that theory alone, but the geographical reason for it is that that part of India is very vulnerable to subsidence. तो वो जो पूरा काठियावाड़ कोस्ट का, गुजरात कोस्ट का जो पार्ट है वो थोड़ा नीचे सबसाइड कर गया, जिसकी वजह से that entire city has submerged. Okay, and अभी हमको उसका बीच बीच में से एविडेंस मिलता है। तो you will find submerged forests, submerged valleys, buildings वगैरह। वो रन ऑफ कच्छ का फेमस पार्ट है अपना, दिस इज रन ऑफ कच्छ, राइट? ये अपना See, ये वो रन ऑफ कच्छ वाला पार्ट है, राइट? अपना दिस पार्ट। सो वी आर सेइंग वो रन ऑफ कच्छ में भी अर्थक्वेक हो गया था, उसके बाद अच्छा खासा सबसिडेंस हो गया, एंड पार्ट ऑफ द रन ऑफ कच्छ वाज सिंपली लॉस्ट। ओके, पार्ट ऑफ दैट रन वाज सिंपली लॉस्ट। सो वी आर सेइंग कि दैट आल्सो हैपेंड। तिरुनेलवेली में एंड सुंदरबंस में हमको पीट एंड लिग्नाइट बेड्स मिलते हैं, वो भी सबमर्जेंस का, बेसिकली वो पानी के नीचे चला गया, तभी जाके उसका डिकम्पोजिशन होकर वो पीट एंड लिग्नाइट बेड्स बन सकते हैं, राइट? सो दैट हैपेंड। अंडमान एंड निकोबार आइलैंड्स का पता होना चाहिए। अंडमान एंड निकोबार आइलैंड्स हैव बीन आइसोलेटेड फ्रॉम द Arabian coast by submergence of the intervening land. Okay, कहाँ नजर आ रहा है आपको, राइट? हाँ, दिस इज गुड नाउ। ओके, यू कैन सी दीज आर अंडमान एंड निकोबार आइलैंड्स, राइट? ये म्यांमार का कोस्ट है, राइट? दिस इज द म्यांमार कोस्ट। हाँ, वहां पे एक अच्छा खासा रेंज है विच इज कॉल्ड एज द अराकान माउंटेन्स। ओके, अराकान रेंज है, अराकान माउंटेन्स है। ओके, तो ये जो है ना, इसका कनेक्शन हम मानते हैं, ज्योग्राफी मानता है कि इन दोनों का एक्चुअल कनेक्शन है, दीज आर इंटरकनेक्टेड। ओके, लेकिन इसका जो कनेक्टिंग लैंड है वो बीच में सबमर्ज हो गया है, दैट हैज सबसाइडेड बिलो द सी लेवल, एंड दैट इज व्हाई यू कैन नॉट सी दैट। एंड आपको सिर्फ ये ऊपर का अराकान कोस्ट दिखता है और यहाँ के ये अंडमान निकोबार आइलैंड्स नजर आते हैं। ओके, सो दिस इज ये वाला जो पार्ट है, दिस पर्टिकुलर कनेक्टिंग पीस ऑफ लैंड हैज सबमर्ज्ड बिलो द सी लेवल, एंड दैट इज व्हाई इट इज नॉट बीइंग You can't see that anymore. Okay, that is just that it. Okay, so ये एक चीज है इंडिया को लेकर जो आपने याद रखनी चाहिए, बिकॉज वो सबमर्जेंस का बहुत बड़ा एविडेंस है हमारे यहाँ पे. ओके, ऑलराइट, ठीक है. एंड नाउ इंडिया के कोस्ट लाइन्स को कंपेयर कीजिए फॉर सबमर्जेंट एंड इमर्जेंट कोस्ट लाइन्स. ओके, ये जो इंडिया का पूरा ईस्टर्न कोस्ट लाइन है ना, whether you consider the Andhra coast, the Coromandel coast, Payan Ghat वगैरह, ये सारा कोस्ट लाइन ऑफ इमर्जेंस है. यहाँ पर आपको इमर्जेंट प्लेटफॉर्म्स नजर आएंगे. दिस वाला कोस्ट इज अ लिटिल अपवर्ड्स. ओके, वो थोड़ा बाहर निकल रहा है समुद्र से. whereas ये मलाबार कोस्ट को भी हम आइडियली कोस्ट ऑफ इमर्जेंस मानते हैं. बट दिस कोस्ट, ये ऊपर का जो कोंकण एंड गुजरात वाला कोस्ट है ना, दैट इज अ कोस्ट लाइन ऑफ सबमर्जेंस. वो नीचे चला गया है. ओके, वहां पे सबमर्जेंस का एविडेंस दिखाई देता है आपको. इज दिस क्लियर? तो इंडिया को लेकर ये सबमर्जेंस एंड इमर्जेंस याद रखिए एंड वी आर गुड ओवर हियर. हैव यू हर्ड ऑफ दिस? ये जो उत्कल कोस्ट के बारे में सुना है, नॉर्दर्न सिरकास. नॉर्दर्न सिरकास की स्टोरी इज, हमको ना जब ब्रिटिश फर्स्ट आए थे हमारे यहाँ पे, तो हमको उनको ब्रिटिश सरकार बुलाने की आदत थी. राइट, वी यूज्ड टू कॉल देम सरकार. सो सरकार इज अ वर्ड विच इज यूज्ड इन मोस्ट लैंग्वेजेस. तो उधर वो जो बंगाली, ओडिया वगैरह भाषा बोली जाती थी, वहां पे भी सरकार इज अ कॉमन वर्ड टू से. ओके, सो the British never understood that they were being referred to as the Sarkar. They thought the land was being referred to as the Sarkar. And that is why they called that entire stretch of वो जो coastal plains है, उसको उन्होंने Northern Sarkars बुलाना शुरू कर दिया. उनका सरकार का स्पेलिंग भी देखिए कितना डिफरेंट है. Okay, they're just called as CIRCARS. सरकार बुलाते हैं वो उसको. Okay, so this is how that Northern Sarkars का story is. It is just a misunderstanding of a word that the British use differently than what we were used to using. Okay. Okay, ठीक है. So the Coromandel coast or the northern Sirkars or the Carnatic plains, these are all coastlines of emergence, whereas this particular, the Konkan coast or the Gujarat coast, are coastlines of submergence. Okay. Now you go to proper orogenic movements. Okay. अब हम ओरिजिनिक मूवमेंट स्टडी करते हैं. ओरिजिनिक माने क्या? माउंटेन बिल्डिंग मूवमेंट्स. ओके, लाइक वी डिस्कस, माउंटेन बिल्डिंग दो तरीके से हो सकता है. हॉरिजॉन्टल मूवमेंट से या तो कंप्रेशनल फोर्सेस एक्ट करेंगे या तो टेंशनल फोर्सेस एक्ट करेंगे. ओके, तो कंप्रेशनल फोर्सेस, आई रिपीट माई सेल्फ, अगर कंप्रेशनल फोर्सेस सॉफ्ट रॉक्स के ऊपर ऐड करेंगे तो क्लियरली फोल्डिंग होगा, है ना. लाइक इस केस में, लाइक आई सेड, ये सॉफ्ट है. ओके, इसको अगर मैं दोनों तरफ से कंप्रेस करना शुरू कर दूं तो इस तरह का फोल्डिंग हो जाता है. ओके, बट इफ आई स्टार्ट टू फोल्ड दिस, a hard object like this, so this has to break. If enough compressional forces are applied, this object is going to break. Okay, so depending on what kind of rock is available, the compressional forces can either produce a folding effect or they can produce a breaking effect. Faulting का जो effect होता है वो produce कर सकते हैं. Okay, now ये जो horizontal movements होती है, in these are called as horizontal movements, right? This is either compression or tension. तो ये जो horizontal movements होती है, इनको हमेशा tangentially act करते हैं, right? They are always acting tangentially ना to the plate tectonics. How is the plate moving like this? How are the movements acting like this? Okay, तो ये tangential act करते हैं, तो इसको tangential movements बुलाएंगे. Okay, दो टाइप्स के मूवमेंट्स मिलेंगे, टेंशन विच इज बीइंग पुल्ड अपार्ट और कंप्रेशन विच इज बीइंग पुश्ड टुगेदर. ऑलराइट, तो कंप्रेशन से फोल्डिंग फॉल्टिंग दोनों हो सकता है. टेंशन से सिर्फ फॉल्टिंग होगा. इट कैन ओनली ब्रेक, टेंशन कैन ओनली ब्रेक, टेंशन कैन नेवर फॉल्ट. ओके, वो फोल्ड नहीं करा सकता है. ये जो मूवमेंट्स होती है ये कंपैरेटिवली फास्टर है. वी ऑलरेडी डिस्कस दिस. 50 से लेके 100 मिलियन साल में पूरा प्रोसेस कंप्लीट हो सकता है. ओके, एंड छोटा पार्ट अफेक्ट करते हैं वो अर्थ की क्रस्ट को एज कंपेयर टू एपायरोजेनिक मूवमेंट्स. एपायरोजेनिक मूवमेंट्स यूजुअली बहुत वास्ट लैंड मासेस को अफेक्ट करते हैं. ओके, एंड वेरी कॉम्प्लिकेटेड डिफॉर्मेशन ऑफ लैंड. हिमालयाज का एक बार स्काईलाइन देख लीजिए, आपको समझ में आएगा कितना कॉम्प्लिकेटेड डिफॉर्मेशन होता है लैंड का, है ना. बहुत कॉम्प्लिकेटेड स्ट्रिगली स्ट्रैगली सर्फेस होता है पूरा का पूरा, तो वो बहुत कॉम्प्लिकेटेड डिफॉर्मेशन करा देता है होल्डिंग लैंड का. ओके, now we go to the different types of mountains. Fold mountains होते हैं. Once again, compressional forces act, folding हो जाएगा mountains का. Depending on कितना severe folding है, mountains उतने ज्यादा complicated या deformed होंगे. Okay, block mountains can either happen because of folding or because of compression or because of faulting. Block mountains का फंडा ये होता है कि वो कुछ ऐसे दिखते हैं. This is how the mountains look. Okay, कि उसका जो नॉर्मली आपको माउंटेन्स देखने की आदत कैसे होती है, ऐसे ऊपर का पीक होता है प्रॉपर, है ना, साइड जैसे इंक्लाइंड होते हैं. यहाँ पर एकदम स्ट्रेट साइड्स होते हैं. ब्लॉक माउंटेन्स में साइड्स एकदम स्ट्रेट होते हैं. वैली भी एकदम फ्लैट बॉटम्ड होती है एंड ऊपर का जो टॉप है वो भी ऐसा टेबल लैंड की तरफ फ्लैट दिखता है. ओके, सो ब्लॉक माउंटेन्स कुछ इस तरह से बनते हैं क्योंकि वो टूट जाता है ना, वो जो सर्फेस ऑफ द लैंड होता है वो टूट जाता है एंड देन दूर किया जाता है. तो इसके लिए आपको ऐसे स्ट्रेट स्ट्रेट सारे एजेस एंड क्लिफ्स मिलते हैं. वोल्केनिक माउंटेन्स वोल्केनिक प्रोसेसेस की वजह से होंगे, वो हम सेपरेटली वोल्केनिज्म में कंसीडर करेंगे. ओके, रेजिडुअल माउंटेन्स को कंसीडर करते हैं. रेसिड्यूअल माउंटेन, रेसिड्यूअल माने क्या, जो पीछे रह गया, रेसिड्यू करके जो पीछे रह जाता है ना, वैसे पीछे रह गया वैसी वाली चीज, ओके, विच इज लेफ्ट बिहाइंड, विच इज रिमेनिंग, विच इज लेफ्ट ओवर, विच इज अ रेमनेंट, ओके, वी आर लुकिंग एट दैट, तो उनको बुलाएंगे रेसिड्यूअल माउंटेन्स। रेसिडुअल माउंटेन्स का फंडा ये होता है कि किसी जमाने में ये वोल्केनिक हो, उनका ओरिजिन चाहे जो हो, फोल्ड माउंटेन्स हो, वोल्केनिक हो, चाहे जो ओरिजिन हो, लेकिन ये ऊंचे ऊंचे माउंटेन्स हुआ करते थे। एट वन पॉइंट ऑफ टाइम दे यूज्ड टू बी रियली हाई, ओके, देन वो माउंटेन बिल्डिंग का जो प्रोसेस है वो बंद हो गया। इसके बाद इसके ऊपर कौन से फोर्सेस एक्ट करेंगे, या तो इरोजन के या तो वेदरिंग के, ओके, दीज आर द फोर्सेस, टू फोर्सेस दैट आर गोइंग टू एक्ट। तो धीरे 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 वो माउंटेन का जो हाइट होता है वो लोअर होते जाता है, ओके, आजू बाजू का पूरा एरिया क्लियर हो जाता है, उसके एकदम फ्लैट एरिया बन जाता है। ये एक इकलौता माउंटेन आपको रेसिडुअल माउंटेन मिल जाता है, ओके। सो इसका फेमस एग्जांपल इंडिया में अरावलीज है। एट वन पॉइंट ऑफ टाइम दे वर फोल्ड माउंटेन्स यूज्ड टू बी रियली हाई, रियली हाई। अरावलीज का आज का हाइट 1000 किलोमीटर के आसपास है, 1000 किलोमीटर से थोड़ा ज्यादा, 1300 किलोमीटर का मैक्सिमम पीक हाइट है उसका, ओके। सो क्लियरली नॉट वेरी स्पेक्टेकुलर, बट अरावलीज आर एन ओल्ड माउंटेन, अ वेरी ओल्ड माउंटेन एंड क्लियरली रेसिडुअल, ओके। रेसिडुअल माउंटेन्स में हमको दो और चीजें समझनी पड़ेंगी। अगर आप इसकी बात कर रहे हो इन कॉन्टेक्स्ट ऑफ टेम्परेट और लिटिल रेनी लैंड, टेम्परेट या थोड़ा सा अल्पाइन लैंड से में बात कर रहे होंगे, तो हम इसको बुलाते हैं मोनाड नॉक्स, मोनाड नॉक बुलाते हैं, ओके, दैट इज द नेम फॉर इट। अगर आप उसको थोड़ा सा ह्यूमिड एनवायरनमेंट में बात कर रहे हो तो इसको मोनाड नॉक बुलाते हैं। रेसिडुअल माउंटेन्स इन ह्यूमिड एनवायरनमेंट कैन बी टर्म्ड एज अ मोनाड नॉक, ओके। यही अगर आप उसको थोड़ा सा एरिड लैंडस्केप में ले जाओ, थोड़ा सा ड्राई लैंडस्केप में ले जाओ, तो फिर उसको बुलाते हैं इंजलबर्ग, ओके। मोनाडनॉक इज नेम्ड आफ्टर यूएसए में एक माउंटेन है मोनाडनॉक, उसके नाम के पीछे पूरा लैंडफॉर्म को नाम दे दिया, चलो सबको मोनाडनॉक बुलाते हैं। इस तरह के पूरे सारे माउंटेन्स को मोनाडनॉक बुलाएंगे, ओके। एंड इंसलबर्ग इज ए ऑब्वियसली जर्मन ओरिजिन है। इंसल माने अकेला, आइसोलेटेड, बर्ग माने माउंटेन, तो अकेला आइसोलेटेड माउंटेन जो होगा उसको इंसलबर्ग बुलाते हैं। प्लीज रिमेंबर मोनाडनॉक्स यूजुअली ह्यूमिड टेम्परेट क्लाइमेट्स के लिए होते हैं। इंसलबर्ग्स यूजुअली आर फॉर्म्ड इन वेरी ड्राई एरिड क्लाइमेट, सेमी एरिड क्लाइमेट्स में बनते हैं, ओके। So those are monadnocks and inselbergs. उसका एक फेमस एग्जांपल मैं आपको दिखाती हूँ, मेरा एक बहुत फेवरेट पत्थर है दुनिया का, किधर गया पत्थर, उलुरु। ऑस्ट्रेलिया में सेंट आयर्स करके एयर्स रॉक बुलाते हैं उसको, उलुरु पत्थर है। अब इसका आसपास का एरिया देख लीजिए, एकदम फ्लैट है, ओके। डू यू सी एनी अदर लैंड फॉर्म ओवर हियर, डू यू सी एनी फॉर्म ऑफ रिलीफ ओवर हियर, नथिंग, राइट, कुछ नहीं है यहाँ पे। सिर्फ ये एक बीच में से आउटक्रॉप की तरह ये बाहर ये हिल या माउंटेन बैठा है, ओके। सो दिस इज अ वेरी फेमस एग्जांपल, दिस इज अ वेरी फेमस एग्जांपल ऑफ अ मोनाडनॉक और एन दिस इज एन इंसलबर्ग राइट ओवर हियर, बट ये रेसिडुअल माउंटेन्स का बहुत फेमस एग्जांपल है, ओके। उलुरु और एयर्स रॉक, अभी तो उसको उलुरु ही बुलाएंगे। इफ यू आर लुकिंग इनटू करंट अफेयर्स, इसके कल्चरल इश्यूज बड़े सारे हैं, बिकॉज ये ट्राइबल, वो जो वहाँ के ट्राइबल्स है, एबोरिजिनल्स है, वो बहुत रिस्पेक्ट करते हैं इस जगह को। फॉर इयर्स ऑस्ट्रेलिया यूज्ड टू यूज इट एज अ टूरिस्ट डेस्टिनेशन एंड पीपल यूज्ड टू गो एंड क्लाइंब ऑल अप ओवर द उलुरु, बट नाउ दे हैव डिसाइडेड नहीं, दिस इज अ वेरी कल्चरली इंपॉर्टेंट जगह है, हेरिटेज है उनका, तो क्लियरली अभी सारे टूरिस्ट को अलाउ नहीं करते एंड सो ऑन सो फोर्थ, वो झगड़े चलते रहते हैं उनके, ओके। सो बेयर इन माइंड कि करंट अफेयर्स के लिए भी ये रॉक इंपॉर्टेंट है आपके लिए, ऑलराइट, ठीक है। So are we good with residual mountains also? Moving forward, now we go to fold mountains. फोल्ड माउंटेन्स, ये देखिए, ये क्लियरली ऐसे हो रहा है, कंप्रेशन होता है क्रस्ट के ऊपर, दोनों तरफ से कंप्रेशन फोर्सेस एक्ट करते हैं। अगर रॉक सॉफ्ट होगा तो वो फोल्ड हो जाएगा, ओके। वी आर टॉकिंग स्पेसिफिकली अबाउट सॉफ्ट रॉक्स, ओके, वी आर नॉट टॉकिंग अबाउट हार्ड रॉक्स ओवर हियर। तो एंड वो क्रस्ट क्लियरली शॉर्टन हो जाता है, कैन यू सी ओवर हियर, वो इतना लंबा क्रस्ट था यहाँ पे, क्लियरली इतना लंबा क्रस्ट था, वो अभी छोटा हो जाता है, ओके। व्हेन द कंप्रेशन हैपेंस द क्रस्ट इज अ बिट शॉर्टेड, ओके, एंड ये इस तरह से फोल्ड होता है, एंटीक्लाइन एंड सिंक्लाइन के फॉर्म में फोल्ड होता है। अपवर्ड फोल्डिंग जो होगा उसको एंटीक्लाइन कहते हैं, द अपवर्ड फोल्ड इज कॉल्ड एज एन एंटीक्लाइन, द डाउनवर्ड फोल्ड इज कॉल्ड एज अ सिंक्लाइन, ओके, उसको सिंक्लाइन बोलेंगे। सिंक्लाइंस हम पहले भी कर चुके हैं, राइट, ज्योग्राफी में, फिजिक्स में, हैव यू डन सिंक्लाइंस बिफोर? No. Okay. No worries. So we are essentially saying कि stresses are being set up in the Earth's crust, okay, and the rocks are subject to these compressive forces, okay. उसकी वजह से bending हो जाएगा rocks का, wrinkling, folding, ये सब कुछ हो जाता है crust का, crust shorten हो जाता है। Please remember these points because once again आप जब folding को and faulting को compare करोगे तो आपको इसमें से डिफरेंसेस बताने पड़ेंगे। एंड पूरी पढ़ाई प्लीज ऐसे ही कीजिएगा कि एक चीज को दूसरे से कंपेयर एंड कॉन्ट्रास्ट करके कीजिए, स्पेशली व्हेन यू गेट सच टॉपिक्स लाइक फोल्डिंग एंड फॉल्टिंग एंड ऑल, ओके, बिकॉज दैट इज द ओनली वे यू विल रिमेंबर व्हाट इज हैपनिंग इन विच प्रोसेस। फोल्ड्स एंटीक्लाइंस अप फोल्ड्स के फॉर्म में आते हैं, डाउन फोल्ड्स जो होते हैं उसको सिंक्लाइंस बुलाते हैं, ओके। These mountains, because यहाँ पे इतना folding हो रहा है and the rocks are under such tremendous pressure and stress. Imagine उसका क्या होगा, इतने सारे stress में वो rocks अपना characteristic change कर देते हैं. Remember, they become metamorphic rocks. Under tremendous pressure, वो rocks अपना characteristic change करेंगे, metamorphic rocks बनेंगे. तो clearly ये बहुत minerals का बहुत rich resource होता है. Okay, most of the fold mountains will give you very huge mineral resources. बहुत ज्यादा मिल जाता है. And volcanic activity के साथ भी associated होता है. In fact, other than the Himalayas, almost all of the alpine mountains, including the Alps or the Rockies or the Andes, are famously associated with huge volcanic activities. Okay, बहुत famous volcanoes associated है. तो आपके चार famous fold mountains of this particular alpine age are going to be Himalayas, Rockies, Andes, and Alps. Out of which Himalayas are still important, right? वो बहुत बड़े होते हैं. चलो यार, very quickly we'll look through different types of folds. Okay. अब जब फोल्डिंग होता है तो डिपेंडिंग ऑन कितना इंटेंसिटी से फोल्डिंग हो रहा है और कितना देर के लिए फोल्डिंग होता है, अलग अलग टाइप्स के फोल्ड्स बनते हैं. ओके, ठीक है. तो सबसे सिंपल, सबसे पहला फोल्ड जो बनता है दैट इज अ सिमेट्रिकल फोल्ड. सिमेट्रिकल माने ऐसा इंक्लाइन होगा, अच्छा खासा इंक्लाइन होगा. क्लियरली दोनों लिम्स जो होंगे वो, इसको लिम्स बुलाते हैं, ये जो होते हैं ना उसको लिम्स बुलाते हैं. ओके, सो बोथ लिम्स आर इक्वली इंक्लाइन एंड कंप्रेसिव फोर्सेस रेगुलरली अप्लाई किए जाते हैं फॉर अ मॉडरेट पीरियड ऑफ टाइम. ओके, मॉडरेट इंटेंसिटी से थोड़ी देर के लिए कंप्रेसिव फोर्सेस अप्लाई होंगे, तब जाके आपको सिंपल सिमेट्रिकल फोल्ड्स मिलते हैं. ओके, सी दिस इज माउंट बोनार्ड. ये थोड़ा सा ह्यूमिड एनवायरनमेंट में है. जैसे मैंने आपको ये इंसलबर्ग दिखाया था ना, वैसे ये मोनार्ड नॉक है. दिस इज अ सिमेट्रिकल फोल्ड. नजर आ रहा है कैसे सिमेट्रिकल है ये? क्लियरली सिमेट्रिकल है, राइट? ये बराबर सिमेट्रिक, दोनों ये जो लिम्ब है, दिस लिम्ब एंड दिस लिम्ब आर एग्जैक्टली प्रॉपर्ली अलाइंड है ना, दोनों प्रॉपर्ली अलाइंड है. तो इसको बुलाएंगे सिमेट्रिकल फोल्ड. ओके, दैट इज कॉल्ड एज अ सिमेट्रिकल फोल्ड. You guys don't seem impressed with the symmetrical fold at all. Anyways, second fold जो होता है that is called as an asymmetrical fold. Asymmetrical fold usually तब होता है, see this, if this was a symmetrical fold, तो asymmetrical fold में एक साइड थोड़ी फोल्ड हो जाती है, दूसरी थोड़ी कम फोल्ड होती है. ओके, सो दिस हैपेंस बिकॉज एक तरफ से कंप्रेशनल फोर्सेस बहुत ज्यादा लग जाते हैं और दूसरी तरफ से उतने नहीं. ऑलराइट, सो दोनों लिम्स थोड़े से अनइक्वली इंक्लाइन हो जाते हैं. Asymmetrical folds look somewhat like this. See this? This is an asymmetrical fold. You can't make out which, you can clearly make out कि एक तरफ से फोल्डिंग ही नहीं हुआ है, दूसरी तरफ से बहुत ज्यादा फोल्डिंग हो गया है. ओके, सो इसको बुलाएंगे asymmetrical fold. ऑलराइट, ठीक है. नेक्स्ट टाइप का फोल्ड जो होता है दैट इज अ मोनोक्लाइनल फोल्ड. मोनो मींस व्हाट? वन. वन, एक साइड एकदम एकदम स्ट्रेट हो जाती है. ओके, इतना ज्यादा फोल्डिंग हो जाता है कि वो एकदम स्ट्रेट इंक्लाइन हो जाती है, और दूसरी साइड पे मॉडरेट तरह का फोल्डिंग हो जाता है, तो उसको मोनोक्लाइनल बुलाते हैं. ओके, मोनोक्लाइनल फोल्ड में लिम्स के स्प्लिट होने की पॉसिबिलिटी काफी रहती है एंड वो अनइक्वल फोल्डिंग होता है. ओके, दिस इज अ मोनोक्लाइनल फोल्ड. मोनोक्लाइनल फोल्ड का ना बेटर एग्जांपल ऐसा स्टेप जैसा होता है. सी, ये वाला पार्ट जो है वो ज्यादा फोल्ड नहीं होता है, ये ऑलमोस्ट स्ट्रेट फोल्ड बन जाता है, तो इट लुक्स लाइक अ स्टेप. इट ऑलवेज लुक्स लाइक अ स्टेप. ओके, तो वो स्टेप जैसा जो नजर आने लगता है दैट इज अ मोनोक्लाइनल फोल्ड. ओके, ये स्टेजेस भी होते हैं. पहले सिमेट्रिकल फोल्ड होगा, फिर एक तरफ से ज्यादा फोल्डिंग होता है तो शायद एसिमेट्रिकल हो जाएगा, फिर इतना ज्यादा फोल्डिंग कि वो एक एक जो लिम्ब है वो एकदम एब्सोल्युटली स्ट्रेट वर्टिकल बन जाए और बाकी का ना बने, तो दैट विल बी अ मोनोक्लाइनल फोल्ड. ओके, मोनोक्लाइनल फोल्ड का जो नेक्स्ट स्टेज है, अगर उसका दूसरा पार्ट देखा जाए तो उसको बुलाएंगे आइसोक्लाइनल. आइसो मीनिंग क्या? इक्वल है ना. आइसोसेलेस ट्रायंगल्स वगैरह याद है, हमने स्टडी किए थे. दोनों एंगल्स, बेस एंगल्स इक्वल होते हैं आइसोसेलेस. तो आइसो मीनिंग इक्वल. आइसोक्लाइनल फोल्ड्स माने दोनों तरफ से इक्वल फोल्डिंग होता है, लेकिन अभी दोनों लिम्स जो है वो एब्सोल्युटली स्ट्रेट हो गए, तो ये वर्टिकल फोल्ड्स हो जाते हैं. ओके, दीस फोल्ड्स बिकम, द लिम्स बिकम पैरेलल बट नॉट हॉरिजॉन्टल. ओके, this is an isoclinal fold. I'll draw the fold for you. Can you see this part of the fold? Can you go up, Ray? Can you see this part? ऐसा नजर आ रहा है आपको ये फोल्ड? हाँ, वो आइसोक्लाइनल फोल्ड हो गया. क्यों? क्योंकि अभी दोनों लिम्स एग्जैक्टली वर्टिकल हो गए हैं, लेकिन एंड दे पैरेलल, द लिम्स आर एब्सोल्युटली पैरेलल एंड वर्टिकल. ओके, उसको बुलाएंगे आइसोक्लाइनल फोल्ड्स. दिख रहा है ना कितना एकदम स्लीकली फोल्ड हो गया है वो. ओके, तो दैट इज कॉल्ड एज एन आइसोक्लाइनल फोल्ड. ओके, द नेक्स्ट काइंड ऑफ फोल्ड बिकम्स ए रिकम्बेंट फोल्ड. ओके, अब ये जो फोल्ड ऐसा सीधा था अच्छा खासा, वो गिर जाता है. ओके, इट फॉल्स बिकॉज ऑफ दैट एक्सट्रीम फोल्डिंग, वो पूरा का पूरा फोल्ड नीचे की तरफ गिर जाता है, उसको कहते हैं रिकम्बेंट फोल्ड। रिकम्बेंट का इंग्लिश में मतलब होता है अ स्लीपिंग पोस्चर। ओके, तो रिकम्बेंट फोल्ड माने नाउ द फोल्ड इज स्लीपिंग। अब इस केस में आइसोक्लाइनल में भी एंड रिकम्बेंट में भी दोनों केसेस में लिम्स आर पैरेलल। ओके, सिर्फ आइसोक्लाइनल में दे आर वर्टिकल, इन रिकम्बेंट दे आर हॉरिजॉन्टल। ओके, आई शो यू व्हाट अ रिकम्बेंट फोल्ड लुक्स लाइक। लड़की को इग्नोर कीजिए, ये फोल्ड सबसे अच्छा है, सो वी आर लुकिंग एट दैट फोल्ड। कैन यू सी दिस फोल्ड? Can you make out this fold? This is a recumbent fold. दोनों limbs actually काफी pretty parallel है, but it is fallen down now. ऐसा नीचे horizontal हो गया है वो fold. Okay, so this is a recumbent fold. इस तरह से recumbent fold दिखा. Can you make out when I'm drawing it? Can you make it out कि वो recumbent है, वो isoclinal है? You can make it out, right? तो वो recumbent fold इस तरह से, because it is sleeping now. The fold is horizontal now. Okay, तो इस तरह से ना horizontal fold नजर आता है. That is called as a recumbent fold. Recumbent fold के बाद अभी आपके पास बहुत कम options बचते हैं. Then you go to a overthrust fold. इसका next stage जो होगा वो overthrust होता है. See people, fold already ऐसा है. Okay, this is how the fold has happened. अभी क्या हो जाता है ना, इतना ज्यादा इंटेंस फोल्डिंग हो जाता है कि यहाँ पर जो जॉइंट था ना उस फोल्ड का, दिस वाज द फोल्ड राइट, ये जो जॉइंट होता है वो टूट जाता है एंड एक लिम दूसरे लिम के ऊपर जाके बैठ जाती है. कैन यू अंडरस्टैंड व्हाट हैज हैपेंड? बिकॉज इतना ज्यादा प्रेशर हो गया है, इतना ज्यादा कंप्रेशन हो गया है कि ये जो बीच में जॉइंट था अच्छा खासा ऐसा आइसोक्लाइनल था, फिर वो गिर गया, वो ये बना रिकम्बेंट बना. ओके, अब यहाँ पे वो टूट गया, ये जो जिस तरफ ज्वाइन हो गया था वहां पर वो टूट गया बिकॉज ऑफ एक्सट्रीम प्रेशर एंड एक्सट्रीम कंप्रेशन, एंड ये जो ऊपर का लिम था इट मूव्ड ऑन टॉप ऑफ द लोअर लिम. ओके, दैट इज कॉल्ड एज एन ओवरथ्रस्ट फोल्ड. ये नॉर्मली ऐसे एक के ऊपर दूसरा थ्रस्ट किया जाता है, पुश किया जाता है, सो दैट इज कॉल्ड एज एन ओवरथ्रस्ट फोल्ड. कैन यू मेक इट आउट? ये जो सेक्शन है, इट इज सिटिंग अटॉप दिस वन. ये वाला जो रॉक है इसके ऊपर ये पूरा का पूरा बैठ गया है. कैन यू मेक इट आउट? ऐसे नजर आ रहा है क्लियरली? वन सेक्शन इज क्लियरली सिटिंग अटॉप द अदर सेक्शन, है ना? तो दैट इज कॉल्ड एज एन ओवरथ्रस्ट फोल्ड. ओके, इसको ओवरथ्रस्ट फोल्ड बुलाते हैं. मैं आपको इसका विजुअल इसलिए दिखा रही हूँ ताकि आपको एग्जाम में अच्छे से याद आए, क्योंकि वो आपको फोल्ड्स के ऊपर मल्टीपल टाइम्स क्वेश्चंस पूछते हैं. ओके, सो यू रियली नीड टू नो व्हाट हाउ दीस फोल्ड्स वर्क. ये एंड क्लियरली हर केस में आपका कंप्रेशन का जो लेवल है वो बढ़ते जा रहा है, बढ़ते जा रहा है. ओके, बहुत ज्यादा बढ़ते जा रहा है. एंड द लास्ट लेवल ऑफ कंप्रेशन दैट यू रीच इज कॉल्ड एज नैप्स. ओके, नैप्स का फंडा ये होता है किसी पहले फोल्ड ऐसा था, आइसोक्लाइनल था, ओके, गिर गया, रिकम्बेंट हो गया, फिर ओवरथ्रस्ट हो गया. अब ये इतना दूर ढकला जाता है, इट इज पुश्ड सो फर्दर अपार्ट कि वो ओरिजिनल रॉक के साथ रहता भी नहीं है, वो किसी और ही रॉक के ऊपर जाके बैठ जाता है. ओके, समटाइम्स फ्यू किलोमीटर्स अवे, 7-8 किलोमीटर दूर तक वो रॉक, दूर धक्का दिया जाता है उसको, ऊपर वाले पार्ट को, एंड वो किसी और ही आउटक्रॉप का हिस्सा बन जाता है. और ये नीचे का जो रॉक है वो क्लियरली आपको लग रहा है कि ये फोल्ड जैसा तो नहीं नजर आ रहा है, राइट? क्योंकि ये फोल्ड का नीचे का पार्ट था, इट वाज नॉट द एक्चुअल एंटायर फोल्ड. जो रह गया पीछे वो फोल्ड का नीचे का पार्ट था, तो इट स्टार्ट्स लुकिंग वेरी ऑड विद द रेस्ट ऑफ द कॉम्बिनेशन. वो जो नैप उधर धक्का देके दूर भेजा गया, वो जो नैप था ऊपर का जो टूटा हुआ हिस्सा था रॉक का, वो जिसको धक्का देके दूर भेजा, तो वो भी उस रॉक के साथ, नीचे के रॉक के साथ मैच नहीं करता है. तो यू कैन क्लियरली मेक आउट, यहाँ पर देखिए, यू कैन क्लियरली मेक आउट कि ऊपर का रॉक नीचे के रॉक के साथ मैच नहीं कर रहा है, क्लियरली मैच नहीं कर रहा है. ओके, तो हिमालयाज में आपको इतना ज्यादा इंटेंस फोल्डिंग हो गया है कि आपको इसके बड़े सारे एग्जांपल्स मिलते हैं. यू फाइंड मल्टीपल एग्जांपल्स ऑफ सच नैप्स इन द हिमालयाज. ओके, सो इट डज नॉट, आपको यूजुअली नैप्स के ऊपर बहुत ज्यादा क्वेश्चंस नहीं पूछते. वंस अगेन दिस पर्टिकुलर टॉपिक इज वेरी फेमसली रिजर्व फॉर द सिविल सर्विसेज प्रिलिमिनरी एग्जाम. ओके, या फिर टफर एग्जाम्स के लिए रिजर्व करते हैं इसको. लेकिन आपको ये जरूर पूछा जाएगा, आपको कभी कभी सिंपली वर्ड्स इंट्रोड्यूस किए जाते हैं, आइसोक्लाइनल फोल्ड्स, नैप्स, ये वो, तो ये किस एंटायर टर्मिनोलॉजी का हिस्सा है, एंड यू शुड बी एबल टू से कि दिस बिलोंग्स टू फोल्ड माउंटेन्स. ओके, कि ये आपने फोल्ड माउंटेन्स में देखा है, ये फोल्ड माउंटेन का टूटा हुआ ब्रोकन हिस्सा है जो धक्का देके कहीं और चला गया. ओके, ठीक है. एंड धक्का कौन ले रहा है? ये कंप्रेशनल फोर्सेस. वी आर टॉकिंग अबाउट कंप्रेशनल forces. We are not talking about human interference at all. Are we good here, people? Okay. Okay. Now we look at anticlinorium and synclinorium. Okay. हमने पहले भी डिस्कस किया था, ये जो स्ट्रक्चर है इसको एंटीक्लाइन बुलाएंगे, ये वाला जो स्ट्रक्चर है उसको सिंक लाइन बोलेंगे। ओके, अब इसी में अगर और ज्यादा फोल्ड्स हो गए, अगर ये एंटीक्लाइनल शेप में ही सारे फोल्ड्स बनना शुरू हो गए, इफ द फोल्ड स्टार्ट हैपनिंग लाइक दिस, तो फिर इसको एंटीक्लाइनोरियम एंड सिंक्लाइनोरियम बोलेंगे। दैट इज व्हाट वी आर गोइंग टू कॉल देम। ओके, ठीक है। एंटीक्लाइनोरियम एंड सिंक्लाइनोरियम यूजुअली तब बनते हैं जब बहुत ज्यादा वेरिड अमाउंट में फोल्डिंग होता है, वेरिड पीरियड्स के लिए फोल्डिंग होता है एंड अनयूजुअल फोल्डिंग हो जाता है, तब जाके आपको एंटीक्लाइनोरियम्स एंड सिंक्लाइनोरियम्स मिलते हैं। ओके, दिस इज व्हाट इट लुक्स लाइक। आर वी गुड? We have 10 minutes to go. Do you wish to do block mountains or do you wish to do questions based on what we learned so far? Questions? ये कर सकते हैं राइट, हम ये वाला क्वेश्चन अटेम्प्ट कर सकते हैं। विच ऑफ द फॉलोइंग स्टेटमेंट्स रिगार्डिंग, या अर्थ के इंटरनल स्ट्रक्चर से रिलेटेड था, वी डिड दैट ऑलरेडी राइट। विच ऑफ द फॉलोइंग स्टेटमेंट्स रिगार्डिंग अर्थ इंटरनल स्ट्रक्चर इज आर करेक्ट? Oceanic crust is heavier than the continental crust. Heavier माने denser. When we say heavy, we say dense. Yes, oceanic crust is definitely heavier than the continental crust, right? Most of the Earth's internal heat is contained within the mantle. Yes, yes, it is contained within the mantle. Mantle Earth का सबसे वॉल्यूम वाइज भी अर्थ का सबसे बड़ा लेयर भी बनता है। ओके, सो ये भी सही है कि मोस्ट ऑफ द अर्थ इंटरनल हीट इज कंटेन्ड विद इन द मैंटल। लार्ज कन्वेक्टिव सेल्स इन द क्रस्ट सर्कुलेट हीट एंड ड्राइव प्लेट टेक्टोनिक प्रोसेसेस। रीड केयरफुली। Large convective cells in the crust circulate heat. No crust, no crust. It has to be in the mantle. Okay, it cannot be in the crust. Those convective cells are not set up in the crust, they are set up in the mantle. So clearly for one single misstep ये पूरे statement को disregard कर देंगे. We'll just go with 1 and 2. All right, ठीक है? Which of the following is found in the innermost part of the earth? Conrad, Mohs, Gutenberg या Lemon? लेमन डिस्कंटिन्यूटी ऑलवेज वी से कि ऊपर कॉनराड होती है, फिर मोरोविचिक होती है, फिर उसके बाद रेपेटी आती है, देन यू गेट गुटेनबर्ग एंड लास्टली यू गेट लेमन। ओके, तो अगर अर्थ के इनमोस्ट पार्ट की डिस्कंटिन्यूटी ढूंढनी हो तो दैट हैज टू बी लेमन डिस्कंटिन्यूटी। चीफ मिनिस्टर्स आर ग्रेट लीडर्स। ओके, गॉट टू रिमेंबर दैट। ये हमने किया नहीं, इंट्रूसिव रॉक्स ये बता सकते हैं आप। विच वन ऑफ द फॉलोइंग डिस्कंटिन्यूटी सेपरेट्स द अर्थ्स क्रस्ट फ्रॉम द मैंटल? क्रस्ट से मैंटल को डिफरेंशिएट करने वाला क्या रहता है? ये अपना क्रस्ट है, ये मैंटल है। वेरी गुड, एंड ये रहा कोर है। ओके, तो विद इन द क्रस्ट आपको कॉनराड मिल जाता है फर्स्ट ऑफ ऑल। नेक्स्ट कौन सा डिस्कंटिन्यूटी है? मोहोस, मोरोविचिक करके जो डिस्कंटिन्यूटी है दैट इज गोइंग टू बी द वन बिटवीन द क्रस्ट एंड द मैंटल। ओके, सो वी गो विद मोरोविचिक। ये सी मैंने आपसे कहा था ना, ये क्वेश्चन पूछते हैं आपको ऐसे। which one of the following statements is are correct? One first statement says the Earth's crust is brittle in nature. The second statement says the mean thickness of the oceanic crust is 15 kilometers, while that of the continental crust is around 30 kilometers. बताइए कौन सा statement सही है? Both statements are correct. We'll go with the first कि ओशन अर्थ का जो क्रस्ट होता है वो ब्रिटल है नेचर में, वो तो हमने एस्टैब्लिश किया। ओके, सेकेंड स्टेटमेंट बोलता है कि मीन थिकनेस ऑफ ओशियनिक क्रस्ट इज 15 एंड कॉन्टिनेंटल क्रस्ट इज 30। चलो, मीन थिकनेस कॉन्टिनेंटल का 30 है, ओशियनिक का कितना बोला था? ओशियनिक का 5 बोला था, 5 कहाँ गया यार? कहाँ था वो? बहुत अर्ली स्टेजेस में था राइट। Thinner average thickness is 5 kilometers. Be very mindful with these little details. Many of the kids जब ये क्वेश्चन पूछा था तो बहुत लोगों ने 15 5 एंड 15 को कंफ्यूज करना कितना आसान होता है। सो मोस्ट किड्स इवन क्लिक दैट कि नहीं वो भी तो सही है। एंड आई वाज लाइक नहीं, 15 आधा तो नहीं था। रिमेंबर ओशियनिक क्रस्ट इज सपोज्ड टू बी वेरी पतला बिकॉज वो कॉन्स्टेंटली रिसाइकल होता है, कॉन्स्टेंटली क्रिएट होता है, कॉन्स्टेंटली डिस्ट्रॉय होता है। इट कैन नेवर हैव दैट, उसके पास उतना टाइम ही नहीं होता है, इतना इट डज नॉट रेस्ट फॉर सो मच टाइम कि वो और इतना थिकनेस एक्यूमुलेट करे। ओके, so it is really thin. So we'll only go with the first question, the first answer, right? सिर्फ ये correct है, ये incorrect है, ये 5 किलोमीटर होना चाहिए था। ये इंटरेस्टिंग है। Maximum depth of the lithosphere is found in the Pacific, Siberian plain, Patagonian desert, Himalayan mountains. Siberian plain कहाँ मिलेगा? रशिया, वेरी गुड। ये जो वास्ट लैंड है यहाँ पे, ये साइबेरियन प्लेन्स है ना, ये साइबेरियन प्लेन्स है आपके। पैटागोनियन प्लेटो कहाँ मिलेगा? अर्जेंटीना, यहाँ पे मिलेगा। दिस इज द पैटागोनियन प्लेटो। नाउ वी आर ट्राइंग टू लुक फॉर पैसिफिक ओशन पता है, हिमालयन माउंटेन्स पता है। अब मैक्सिमम डेप्थ ऑफ लिथोस्फीयर आपको कहाँ मिलेगा? हाँ, पैसिफिक में मिलेगा। वेरी गुड, एब्सोल्युटली करेक्ट। रिमेंबर मरियाना ट्रेंच, हाँ, Mariana Trench is supposed to be how much? 11 kilometers deep, right? Challenge 11, 20 kilometers deep. Huh? What are you saying? देते हैं मुझको, मुझे सचमुच लगा 20 किलोमीटर हो गया, मुझे पता नहीं चला। आई वाज लाइक आई एम वॉकिंग अराउंड विद द रॉन्ग डेटा इन माय हेड। 11 किलोमीटर्स, ओके, विल गो विद 11 किलोमीटर्स इज द डेप्थ ऑफ द मरियाना ट्रेंच। ट्रेंच है वो क्लियरली सबडक्टिंग प्लेट्स है, तो वहां पे ट्रेंच बन गया है। एंड वो ट्रेंच जो है उसका, उसमें जो एक चैलेंजर डीप नाम की जगह है, इनफैक्ट दैट इज द डीपेस्ट पॉइंट एंड दैट इज सम 11 किलोमीटर्स। पूरा मरियाना ट्रेंच वहां का नहीं है। एंड बाय द वे आई शुड टेल यू दैट इवन दो दैट प्लेस बिलोंग्स टू फिलीपींस, वो फिलीपींस के बाजू में आता है, राइट? वो जगह मरियाना ट्रेंच आइडियली शुड बिलोंग टू फिलीपींस, लेकिन वो एंड उसका सराउंडिंग नेशनल पार्क जो है वो सब यूएस के अंडर जाता है, बिकॉज फिलीपींस वंस यूज्ड टू बी अ कॉलोनी फॉर द यूएस, so clearly it still happens to be under that jurisdiction. Okay, then क्या है आपके पास? Himalayan mountains का ना, the first time I saw this question my mind automatically went to Himalayas, because I was thinking not, I was thinking the maximum depth as in the thickness. I was not looking at the depth, I was thinking of the thickness. So be careful of these traps also. Clearly वो isostasy में clearly नीचे भी बहुत depth है हिमालयाज को, उसके नीचे भी बहुत है, तो I was thinking the depth of lithosphere is there, and then I thought नहीं, you have to go deeper, right? So that has to be Pacific. Anyways, ये बताइए, which one of the following best describes the lithosphere? Upper and lower mantle, crust and core, crust and upper mantle, lower mantle and core. Crust and upper mantle. We say ये crust है, okay? Then we say ये पूरा का पूरा mantle है, okay? ये पूरा section mantle बुलाते हैं हम लोग, okay? इसमें अभी एक upper mantle है, एक lower mantle है। उसका जो uppermost solid mantle है ये, एंड वो क्रस्ट वाला पार्ट जो है उसको कुल मिला के हम बुलाएंगे लिथोस्फीयर, ओके? दीस टू टुगेदर आर कॉल्ड एज लिथोस्फीयर। ये जो अपरमोस्ट सॉलिड मेंटल है उसके नीचे एक एस्थेनोस्फीयर है, ओके, विच इज द मोल्टन लावा। सारा मोल्टन मैग्मा जो है वो वहां पे है, वो मोल्टन स्टेज में है। पूरा का पूरा लिथोस्फीयर जो है वो उस एस्थेनोस्फीयर के ऊपर अच्छे से फ्लोट करता है, ओके? सो वी आर गोइंग विद क्रस्ट एंड अपरमोस्ट मेंटल। सी, दिस इज नॉट मी, वो ये खुद ने, उन्होंने ये क्वेश्चन दो डिफरेंट एग्जाम्स में रिपीट किया था बैक टू बैक। लिथोस्फीयर कंसिस्ट ऑफ अपर एंड लोअर मैंटल, क्रस्ट एंड को, क्रस्ट एंड अपरमोस्ट सॉलिड मैंटल, मैंटल एंड को। उन्होंने ऑप्शन भी नहीं बदलाया, एग्जैक्ट क्रस्ट एंड अपरमोस्ट सॉलिड मैंटल, ओके? वी आर स्टिल गोइंग विद द सेम क्रस्ट एंड अपरमोस्ट सॉलिड मैंटल। Which one of the best following describes the lithosphere? Upper and lower mantle, crust and upper mantle, crust and core, mantle and core. B, crust and upper mantle. Okay. You see the importance of that topic. They have asked this question thrice in 3 different exams. Okay. ये तो जनरल ज्योग्राफी करके भी आंसर कर सकते हैं आप कि which of the following factors does not affect the distribution of groundwater. You don't need to really study anything. ये जनरल अमाउंट ऑफ प्रेसिपिटेशन अफेक्ट करेगा ग्राउंड वाटर के लेवल को। हाँ, जितना ज्यादा प्रेसिपिटेशन उतना सीपेज के चांसेस, प्रोबेबिलिटी ज्यादा। रेट ऑफ इवेपोरेशन, यस, अगर रेट ऑफ इवेपोरेशन ज्यादा होगा तो क्लियरली वाटर लेवल्स भी उतने ज्यादा नहीं होंगे। एबिलिटी ऑफ द ग्राउंड सरफेस टू अलाउ वाटर टू इन्फिल्ट्रेट इनटू द ग्राउंड वाटर सिस्टम, यस, दैट विल आल्सो मेक अ डिफरेंस। डिस्टेंस फ्रॉम द सी अफेक्ट करता है क्या? नहीं, कभी नहीं करता है। डिस्टेंस फ्रॉम द सी क्यों अफेक्ट करेगा वाटर के लेवल्स को? इट डजंट अफेक्ट यू, इट विल डिपेंड ऑन दीस 3 डिफरेंट फैक्टर्स, ओके? करेगा ना, बिल्कुल करेगा। जितना ज्यादा बारिश होगा उतना प्रोबेबिलिटी ऑफ द सीपेज ज्यादा होगा ना। अगर हम अज्यूम करते हैं कि सैंड जैसा सरफेस नहीं है, कोई अच्छा ब्लैक, अपने अपने यहाँ जैसे ब्लैक सॉइल है वैसा कोई सरफेस है, ओके, लेट्स टेक दैट चांस, तो जितना ज्यादा प्रेसिपिटेशन उतना ग्राउंड को इन्फिल्ट्रेट करने की पॉसिबिलिटी ज्यादा। सैंड होता है तो मुश्किल है बिकॉज वो होल्ड नहीं करता है पानी को, तो वो क्या करता है सारा का, इनफैक्ट अगर डेजर्ट में बहुत ज्यादा बारिश आ जाए तो आपको वो फ्लैश फ्लड्स मिल जाते हैं। रिमेम्बर राजस्थान में, राजस्थान की तरफ अगर बहुत ज्यादा बारिश हो जाती है तो बिकॉज द सॉइल इज सो सैंडी, तो वो सैंड होल्ड नहीं कर पाता ना, तो इसके साइज, ग्रेन साइज जो होती है वो बड़ी होती है, तो वो पानी को कंटेन नहीं करेगा, पानी को नीचे लेके जाने की कोई सिस्टम नहीं है, तो वो सारा पानी जमा हो जाता है एंड देन बहने लगता है, सारा का सारा पानी बहने लगता है एंड वो बहुत फोर्स में बहने लगता है। तो फ्लैश फ्लड ज्यादा स्केरी थिंग ओवर देयर। बट यही अगर वी अज्यूम कि सॉइल ठीक ठाक होगा तो जितना ज्यादा प्रेसिपिटेशन उतना ग्राउंड वाटर लेवल्स बेटर होते हैं। हैव यू एवर बीन टू, आई डोंट नो, यूजुअली जहां से आप एग्रीकल्चर के लिए, जहां से आप वेल्स या ट्यूबवेल्स वगैरह यूज करते हो ना, ट्यूबवेल्स तो खैर मैकेनिज्म ही अच्छा है, लेकिन नॉर्मल वेल्स के ऊपर जब आप डिपेंड करते हो तो बारिश के बाद यूजुअली यू नोटिस दैट वाटर लेवल्स आर अ लिटिल बेटर, राइट, बिकॉज द अमाउंट ऑफ precipitation is greater. Obviously the possibility or probability of the water levels rising in the groundwater will be greater. Okay. Oh, this is different. इसका नहीं किया, लेकिन टाइम हो गया है अपना। हाँ, कितने खुशी से हाँ हाँ बोल रहे हो सर, आपने ध्यान कितना दिया होगा, आई रियली डोंट नो। चलो, I'll end the lecture. Thank you very much for your support, people, and you're sitting over here for another 3 hours. That is really great on your part. Stop, man. एंड करो, ये मीटिंग कर रही हूँ मैं। ये लिनोवो ये है या वो कुछ और ही है?